In this video, you're going to learn a simple and repeatable workflow for building apps only using AI. And you don't need hundreds of Claude skills and specialized agents and all these overcomplicated mechanisms and strategies. This is the only thing you're going to need. That means after watching this video, you can confidently build production-grade apps only using AI. Now, we all know the hard part isn't to get AI to write code. It is to keep writing good code as your app grows. And if you've stumbled across common roadblocks in the past when building with AI, like hitting your context windows and session limits, AI inventing files, not being on track, not following the architecture, not building secure code, or building with AI feels more like vibe coding, which is you just prompt your way to vibe an entire app. That is the absolute worst way to build an application. And if you're having a hard time trusting the code that AI generates, then this video should solve your problems. You're going to learn a system of building with AI that I call guardrail coding, or the architectural guardrail itself. It is the exact system that I used to build funnelmods.ai and Mochi only using AI. And to put this in perspective, Mochi has 1,200 features that were built to production in 4 months using the exact architectural guardrail that you're going to learn today. And before I ask you to invest your time to watch the rest of this video, I want to show you that this actually works, to prove that the system does what it's supposed to do. So here are real people who have tested the architectural guardrail, and here's what they have to say. So Sunny here built 4 apps in under 21 days, and he says, not just that, his token consumption also went down drastically. He also reduced his cost by switching from Claude Max 20 down to 5x plan. It's because the architectural guardrail has this implemented inside it, which is token optimization. And the other thing is this strategy, this system will work regardless of whether it's Claude, Codex, Cursor, it does not matter. It's a system. And he says, you've taught me something that I can use no matter if Claude exists tomorrow. Awesome. Here's Jethan. He says, Parents' architectural guardrail actually works. He built his whole LinkedIn publisher without holding its hand. So you can read through this as well. Here's Damien. In 10 hours from an empty repository. And he also adds proof, which is the screenshots to his app. And he shows it down below here. He says he never wrote a single prompt because the architectural guardrail comes with all of the stuff pre-built into it. So he says he could focus and put all his attention into the main features of his app instead, which is the audio. And that's the only reason why this took a day, not a month. And I got more. Obviously, here's Saeed, right? In under 2 days, he built his whole LinkedIn DM SaaS. And in 9 hours, the entire pipeline was already working. Here's Ruby. His app, the core of his app is also working. Here's Michelle. She posts her win, and this is her app as well. And she's also excited. Cool. Here's Jan. He says he shipped his first architectural guardrail feature. And his app is a little more complex, which is a multi-tenant modeling app. And this just proves that this system will work for any scale. Right? Super, super cool stuff. He says AI built it correctly as he requested. He typed in plain English and AI built it correctly through the guardrail. And here's Stephen. In about a week's time, he says, massive shout out to Parent for giving us a methodology to build an app that can scale as we add new features. And here's Ido, who fixed a bottleneck that's been bothering him for a while in 2 hours. And here's Jethan again, who just shipped the second feature for his app. And so this just proves that this system will work. And I hope this is giving you the confidence that you're in the right place. So here are the modules we're going to cover in today's course. Now, each of these modules are a single part of a layer that's a part of the architectural guardrail. The architectural guardrail itself is not just one concept, or it's not just architecture only. It's all of these things working together. It's a system in place that's going to help you build better apps. Okay, so the first thing I want to cover is the mindset. And just to show you what's possible with the architectural guardrail, I'm going to show you Mochi, which is funnelmods.ai, my own company. And the cool part here, guys, is the website for funnelmods.ai is built inside funnelmods.ai. I just thought it was a cool way to demonstrate what's possible, in the app. But more importantly, I just want to point out, to build an app at this scale, or to build these many features, there has to be something in place that I had to do to get all of this done in 4 months. So here's the dashboard, for example. We have a dashboard, we have an inbox page where we can get all emails, we have products, we have website builders, form builders, CMS tables, and that's actually how this was built. So whatever you see here on the pricing page was plugged into a CMS builder that is plugged into a CMS list that has components. And that's why all of this looks the same and can be reusable, but can have different data. And we also have leads, lead list, tracking. We also have custom data, marketing, email templates, like pipelines, automations. Like, look at all of this stuff, right? So here's an automation builder, and you can pretty much build whatever you like in here. But just to show you, one more thing is if I navigate between the pages we just accessed, notice how blazing fast all of this is, right? There's no loading speed. Well, there is a loading speed when you first land on the page, but there's no loading speed after. And when I make a change somewhere, that instantly updates data. So it's optimistic UI. And so all of these architectural practices, the good coding practices, are part of the architectural guardrail. And hopefully this inspires you guys. Like, you are capable of building something like this by yourself or using AI, which is the purpose of this whole video, which is to inspire you to use AI, use Claude Code, and build apps like this to production. And so that brings me to my first point here, which is you're not learning how to code, you're learning how to direct. If you believe that the only thing required to build apps like Mochi or funnelmods.ai is technical skill, then how are other members who have tested this out able to build their apps? Some of them don't have any web development experience. And so what I want to point out here is the most important skill when you're building with AI is not only your web development skills. That's not the most important thing. That will help because that's a leverage. And the reason why I believe this course is going to work for most of you guys watching this, because I'm hoping you are a web developer, is because you already have what it takes. The only thing you need to learn now is a skill to direct AI, to give it guidance, and to point it in the right direction, which is something we'll learn later on, known as pattern recognition. And so by learning this skill to direct AI, you learn to control what AI sees. You don't have to tell it exactly what to write. Imagine if I was to actually plan out each and every single feature you see here. Every single thing, right from start to finish, architecture, and imagine I hold AI and I tell it to build each and every single feature you see here. How long do you think this would have taken me to build? Probably 2 years. But this was built in less than 4 months, and I'm still pushing awesome updates to this software. And so the point is, don't focus on trying to use your web development skills to overpower direction. That means web development skills comes second. You just need to point it in the right direction and give it your thoughts or give it analogies. Sometimes when I'm building good architecture, I don't like to think about code only. I like to think about processes. I like to think at a global scale. That means, what can I have here that can be reusable? And I try to connect real world situations to it so I can help give an analogy to AI, and then it understands what I'm trying to build. And it also understands what it needs to build as well. And that way, all features in your app kind of connect to each other. So I'll give you one example. So most of these features that were built here were obviously built independently, right? And then I introduced Mochi AI, which is essentially an AI agent that allows you to control everything inside the software. And so that's why Mochi or funnelmods.ai is an agentic AI-powered CRM. That means you don't need to interact with the software as much. And that's the goal, at least. That's the vision. That's what I'm hoping I can accomplish. And my first step is this, right? But the point here is all of these features were built individually. Just imagine if I built those individually, how was I able to connect this Mochi AI feature with just one prompt? The reason why I was able to do this is I thought at a global level before even starting anything, right? And so my prompts were more about telling AI that eventually I'm going to have these features in place. And so this is the most important lesson you're going to learn in this module. And I want you to get a piece of paper and a pen and write this down. You want to prompt into the future, not in the present. That means imagine all the features that you will eventually have in your app. What would that scenario look like? Now, obviously, you can't think of everything right now, but what I'm speaking about is the vision. What do you want to accomplish? And if you are building a feature in the present, think just one step higher. What can I do right now to make this feature reusable for something else? Try to expand. You could use AI itself. You could tell AI the problem that you're having and or the feature you're trying to build, and you can tell it to break it down using this principle, which is to think about prompting into the future. And so another example is when I built the schema the Prisma schema, which is a database structure for Mochi, which obviously is huge. The way I did so is by asking AI to build something into the future. And I asked it to track data that I may not have in the current, but might possibly have in the future. And so some features actually stemmed from that. For example, affiliate marketing. I was not going to have affiliates as part of funnelmods.ai, but then because my data structure allowed for this, AI had this suggestion. I was like, oh, that's a cool idea. And so just keep this in mind. You want to prompt into the future, not in the present. And finally, this is the gold rush for web developers. And so take advantage of this. And I'm not saying you should rush into something, but what I'm saying is just be aware that this happens every, once in 3 years, where this crazy surge or this hype about a topic ends up showing up in the marketplace. And then some people figure it out and then they make it big. And so this is the only time in history where web developers can essentially replace themselves. This never used to exist before. The biggest cap to web developers before was our time. The only way for us to make money before was exchanging our time. But now time in some way became our leverage. And the way this is possible is because of AI. Coding with AI is going to be the most important skill in this year and the years to come. I added one more point that I believe is super, super important. If you can't understand code that's in your own application without reading documentation, neither can AI. So here's an example on the screen. I want you to look at this and tell me, without reading any of the documentation, what's happening in this file. What is this file? Just make a guess. Okay, well, without needing to read anything, I can see list, update, and delete. Cool. I understand this is some sort of way to change or manipulate data. And you'll also see a pattern here. You can establish common patterns in this code. You see protected procedure, you see something called required permission, and you see this happening multiple times. And so the next time I ask you to build a update list or an update API endpoint, you probably know exactly what to write. And that's the same experience you want to create for AI when it's reading your code or building new features into your app. All right, and that brings us to the end of the mindset module. The next step is getting Claude set up on your local machine. So let's go ahead and do that next. So now the next thing we need to do is to get Claude set up. So what I'm going to do here is I'm going to open up Claude's website so I can go to Claude's pricing page, and now I can select the plan that I need. Now, I recommend you get the $100 per month plan, and I'll show you why the system will pretty much never need you to go to the $200 plan. I mean, at least most members have already tested this, including me, are on the $100 per month plan. Okay, you're not going to need all the 20x usage. So go ahead and click on Try Claude and then open up an account, and then we'll move on to the next stage. So now we need to install Claude in the terminal. This is how I like to use Claude. Some people use the UI itself, the desktop app, and that's completely up to you. I don't prefer that when I'm coding. I might use that only when I'm researching or maybe I'm just brainstorming or talking to Claude. That's pretty much it. So go ahead and open up this link, and you can just simply Google install Claude code, right? Quick start, and you can click on the quick start guide right here, then scroll down here, and you should find install Claude code. And then down here, you're going to find the exact command you need to run. So go ahead, copy this command based on whichever operating system you're running, and then hit enter in your terminal. And once you're done, you can go ahead and verify that Claude is actually installed by running this command. So now we are all set, ready to go. And just a quick heads up, if you run this command and you don't see Claude, just shut down the terminal, restart the terminal, and try this once more. It should work. Now, the next step is to actually run this inside our project. So what you would probably want to do is create a folder outside, or if you already have a folder with your project, drag and drop that into Visual Studio Code, because that's where we're going to run Claude. So Claude can actually access the file. So this is a project to have open. So I'm going to open up the terminal, and this is the command I'm actually going to run. Now, just some word of advice. Heads up, be aware that this is a destructive operation. Do it at your own risk, okay? But so far, I trust Claude. I'm doing this because I know it works. And so I'm going to hit enter. Boom, nice. So now I have Claude running. And the command is essentially dangerously skip permissions. And what this essentially does is it has full bypass access. So it's not going to ask you to hit approve or click on some weird thing. Like, it's just going to do its thing, and then you come back to it later on, take a look at it if you really need to. So now you're running Claude inside the Visual Studio Code terminal. Awesome. Now, I already have a Next.js application spun up, and this is the architectural guardrail template that we're going to be looking at. And I'm just going to kind of walk you through everything, give you a tour, and show you how everything is set up. So this is Next.js. You can go ahead and install it if you'd like, or you can choose your own tech stack. It wouldn't really matter, but I'm hoping you can also kind of build this with me as I, kind of walk you through everything. So the first most important part of your build is your CLAUDE.md file. Okay, so go ahead and create a Claude file. And the way I like to create this file is inside a Claude folder. And notice I don't have any skills. I don't have any sub-agents. I'm not saying they're bad. All I'm trying to say here is this is the absolute minimum you will need to build great production grade code. That's it. That's all you're going to need, right? Don't overwhelm yourself with all these crazy workflows and stuff right now. First, figure out something that's working and then improve it as you go. So you want to create a claude.md file just like this. And the first rule I want to point out is you're going to scroll all the way to the bottom of your claude.md file, and you're going to add this note here. Don't use Git. Okay? The reason is because Claude sometimes will try to read session history, will try to read all of your commits. And I've had this happen so many times to me where it decided to kind of undo some changes it made. And it thought since it's working on the session, it knows about the session, it's going to undo everything and then rebuild that. And so I just lost all my work because it assumed that the entirety of those commits was what it's working on. So just go ahead and add something like this in here so it doesn't actually try to access Git without your explicit request. Next, everything you build from today is going to need to be on its own branch. So open up another terminal, and you're going to always do this: git checkout -b, and you're going to create a new branch with a new branch name. I do this because sometimes I like to experiment, and sometimes I just want to one-shot prompts, right? I want to one-shot a whole feature. And when I do it this way, I am confident that my main branch is not going to get corrupt. And I can also create multiple versions of the of whatever I'm trying to build. For my website builder, I had, I believe, version 5. So the code base itself was named v5 because a website builder took 5 attempts. So I had 5 different versions. And the only way for me to kind of figure out which one was perfect is to iterate through all of these with different branches. So I created a branch from where I believed was a good checkpoint, and then I created v5.1, v5.2. Then I just kept creating branches until I was good to go, until everything looked good. So make sure you create a new branch for each feature you're working on. All right, so we just finished setting up Claude. Now it's time to understand all of the layers. Just have a 10,000-foot overview of exactly what the architectural guardrail is. So in this module, we're going to look at what the architectural guardrail is. Essentially a 10,000-foot overview, so we understand how the concepts kind of work together. But this is not going to be the in-depth version. In the next modules, we're going to dive deeper into each and every single layer. But first, in order to understand what's right, we need to understand what's wrong. So let's look at what we've been doing wrong all this while so we can correct that. So you see, the old method is us web developers, typically, we leverage our web development skills. And in our prompt, we have the features, obviously, that whatever we're trying to build, but we also have architectural guidance. And so we try to enforce architecture. We try to create all this stuff from scratch. We try to build our own version, or we try to write down exactly how the app should be built. And now that's okay. That's what we're supposed to be doing as web developers. But this is a little slow. Like, if you were to think about every single thing, it's going to take you forever. And not just that, whatever you build, whatever architecture you're trying to figure out, you also have to constantly mention these things: auth checks, permission checks, team members, org scoping, rate limiting, usage checks. Like, you have to mention all of these things. And so that means you're relying on context being the reason why your app is going to be built production grade. And I'd like to show you a different version of this, or a different angle to this, and that might probably make a little more sense. But just to kind of add on top of this as well, what we would typically do in order to implement this then as a solution, because of all these problems, right? We need to think of all of this. We'd instead stop thinking about it and we'll put it into a docs folder. So we'll name the architecture, we'll name whatever we need here, and then this docs folder is the source of truth. And so AI knows exactly what to build based on the docs folder. And so the problem here is when you're relying on something external or relying on context only to be the reason for your app to be production grade, if AI hallucinates because it's out of context window, which it will probably run out of really quickly, and I'll tell you why in just a second, your app will no longer be built the way you want it to. It's not going to use a system, it's not going to use a pattern, it's going to follow what its brain thinks. And so we can't really rely on this. We shouldn't rely on this. And so the question then becomes, is there any way we could build apps without solely relying on context? Because we could just remove this whole docs folder, if we can remove all this stuff and have AI still give us a production grade outcome, that would be nicer. That would be much better, right? Because now your entire context window, which used to look like this all the way, and this whole bar filled purely based on context from your documentation, will now end up like this, right? And that's what I want to show you in the next diagram. So let's take a look at this. So the first step is to stop thinking about those things, which is auth, permissions, planned, limits, rate limiting, etc. And we're going to put that into a block, essentially. The block is a single source of truth. It is a pre-built system that just does its thing. And whatever feature we're trying to build, whatever we're trying to construct here, the architectural progress we make, and I'll show you what we're going to be doing there, but the architectural planning we're going to be making is only for this feature. So that means, how can we focus purely only on this feature and forget about all these things? This way, you can build an app in 2, 3, 4 days, 5 days. And now the most important thing is, because we can essentially leave the whole burden of deciding what this stuff needs to look like every single prompt, we can now confidently rely on AI making the architectural plan. And so we tell AI to do the architectural plan and we nudge it if we need it to. And because it's so focused on only these features, it's easier for us to build. And the coolest part here, if you want something new added to this block, if you add it in here, it applies to all features that were built in the past. So this is a much better architecture. But here's another point I want to emphasize on. Instead of relying on context, we rely on errors. So that means the errors tell AI what it needs to do. Now, when I say errors, I'm not talking about literally only errors throwing up, like undefined errors, not just that. I'm talking about linting errors, compilation errors, whatever type of error you can provide to AI. I feel like this would be a better way to build. And even better, if you could provide this context while it is building. That would be cooler, right? Because now it doesn't have to go all the way to the end, fail, and then realize it needs to loop again. And so as it's building, guys, as it's building, the block essentially will send this kind of echo signal to it. And what's an echo signal? Just this is the type of linting system that we're going to learn inside this course. But imagine it's sending this kind of an echo signal. And each of these echo signals have a structure to follow. For example, provide input, provide ID. You have to provide user name. I'm just giving examples. And if it's trying to build this out, and while it's building it, if it gets this echo signal as context, do you see how much more efficient this could be? We could drastically reduce that context window that previously got swallowed up by this huge docs folder right here into just micro context injection. That means when context is required, it's plugged in tiny little pieces. And as it's reading, it will know what patterns have already been followed. And because these echo signals are going to give it patterns, are going to give it the structure, are going to give it guidance as it's building and as it's essentially generating AI code. And if there was something that it absolutely missed out on because the block had something in here like permissions and it did not provide a permission or whatever, and if the block throws an error, a literal error, you can enforce that to not let the code compile. And so we are now not relying on context to make the app production grade, but relying on some sort of a linting error, some sort of echo signal that literally tells AI you've built it wrong, you need to fix this. In my opinion, this is more reliable, and this is why I can trust AI to build an entire feature for me because I know it's going to go through the same system we've already written in the past. And so here's another diagram on the screen. I want you to take a look at this. If you're overwhelmed, I promise you we're going to kind of break this down so everything makes more sense. But let's go step by step. Imagine if we had a source of truth, one place for everything, right? And this everything decides all of the features or all of the little blocks inside this. That means it's sort of like a helper. So we have a source of truth architecture, and all of our, essentially our linting errors comes through Zod schemas, it comes through permissions, it comes through linting, comes through TypeScript, it comes through compilation errors, it comes through all of these echo signals, essentially, that tell AI exactly what it needs to do in order to complete the entire feature. And because it's plugged into the block, which is called protected.typescript inside the app, it automatically goes through all these checks. So much easier, right? And then it goes through our layers, router and service layer. A router layer does business level logic, and so you can always control exactly what the user can do with this feature. For example, only 5 team members should be on an account. I'm just giving an example. I don't think this is the best example, but let's say only 5 members can be live on a website editing it, right, in real time. Business logic exists in here, and then it accesses the server, but this is only server only, so that means it can never be reused on the client. And so what we have done here is we're essentially throwing a literal error here. We're throwing an error if it tries to access a server action outside of our pre-built block system. So I just wanted to point out, if you're looking at this right now, I just want to point out one specific thing. We're no longer relying on context. Context is the only thing that helps us provide this sort of micro context to AI. That means in tiny little chunks. That's the only way we're going to rely on context. And the way we're going to rely on context is not through external documentation. And the main way is through these echo signals and through systems and pre-built blocks that are inside the code base. Okay, so that should wrap up a 10,000-foot overview of the entire architectural guardrail, or at least share some concepts as to how the whole system works and a different angle or a different perspective. Now it's time to pretty much jump into every single layer, so let's move forward. So here's a quick little experiment. Just participate in this with me. I just want to show you how your brain is thinking. So let's say I told you I want you to have a productive day right now. How do you approach this? I haven't given you any context, and I just told you to have a productive day. Just think about this for a second. So go ahead, pause this video and try to think with me. And then once you're done, you can come back. Okay, so notice how when you thought about what was a productive day, the first thing you had in mind was, what did I do first thing in the morning? Then what did I do next? What did I do later in the evening or in the afternoon? And so you have these it's sort of like little markers in your day. And these markers create patterns over time. So if you do the same thing for multiple days, you build a pattern. Very straightforward. And so you determine what a productive day is based on the patterns that you see throughout the rest of the week or the rest of the month or what you've been following so far. If you do one thing differently, let's say if you have 500 different days that you follow the same exact pattern, but one day in between, you decided to wake up and instead of leaving your phone, you decided to scroll on social media. You've broken the pattern. But that doesn't mean the pattern is bad. It doesn't mean the pattern is forgotten. It just means that this is not in line with the other 500 other days that you were on track with the same pattern. And so that's exactly how AI thinks as well. It follows a linear path. When you tell AI to build a feature, it follows a linear path. What has already been followed in the app? What did it do for authentication? And so this linear path is what needs to be as clear as possible. So right now, if I asked you to build a feature into your app to vibe code, let's say you're not going to do guardrail coding. I just told you to vibe code a feature and you enter the prompt and hit enter. Can you map out that linear flow as to what AI needs to do in order to build that feature to production? If your answer is no, that clearly means there's no pattern in the app. And so step number one is we need to establish a pattern, because if we don't, then what AI is going to do is it's going to look at all these different patterns that are very inconsistent, and it's going to think, okay, I need to use one of these. Let me decide which is the best pattern. And then it tries to become creative there, and it creates its own little pattern, and eventually that's just code drift, right? That's a whole different tech debt problem there. So essentially, what I want you to do from today is everything you're coding, everything you're building needs to have a pattern in place. And I'll show you the same pattern that I'm using, and the same pattern that's inside the architectural guardrail, which makes this so easy and simple to build into. But just remember, AI builds on patterns. And if your code base doesn't have correct patterns or a more systemized, repetitive pattern being used, then it's going to use something else. So now I'm going to show you a pattern inside my code base that makes building features very linear, straightforward. So the way this works, let's go into the code actually. Let's take a quick look at this. So first thing is inside the source folder, I have something called trpc. Now, I use trpc because the linting, essentially the echo signal, which we'll get to later on, forget about that for a second. But if you look at this, I have something called as a router layer, which we looked at in the start of this course, right? You see, each of these has a straightforward pattern, protected procedure. And inside that, you see there's something here called required permission. And there's also other sorts of data required in here as well. And it looks something like this. We have require role, permission, paginate, audit, and some other timeout. You don't really need to care about that for now. But the point is, it's straightforward. When AI is building an API endpoint, it knows it has to use this protected procedure. Why? Because you see it being used everywhere. You see source of truth architecture. You see something being like something is literally directing it as it's building. And so the pattern is so recognizable. So it knows, okay, I need a protected procedure, and I know required permissions need to be passed in for this specific endpoint. And then it asks itself, is this actually the same pattern in other places too? And yes, obviously. You see, we have update for organization setting. We have delete for organization setting, the exact same thing. And it also looks at this right here, which is what else should it audit? What type of role is required? And this right here throws that echo signal that I was talking about. And so it enforces and tells AI that you need to give us something in order for this to compile. And so just by looking at this, you probably already understood the entire structure of how the app works. If you were to build this feature yourself, you would know that I need to create this router here, and then I need to create get, update, delete, and leave whatever endpoints. And then I need to use a protected procedure. Even though you don't know the code, you can understand what you need to do. And then you see permissions. Do I really require permissions for this? Probably, most likely. And oh, wait, require permission is throwing an error. That means I 100% need to provide the permission. Do you see what I'm saying here? That's how you implement a pattern along with our with no context, error-only approach. And so that brings us to the end of the pattern recognition module. Now let's move on to the next stage. In this module, we're going to learn about globalization, which is my favorite topic because this is what makes it easier for AI to understand how to reuse stuff in your app. So just a quick side note, all the modules we've gone across so far, they act as supplemental content to the big picture. So in the end, or in the next few modules, or maybe towards the end of this course, we will learn how to bridge all of this. Like, how do we take the concepts and kind of make AI implement all of these? Like I said, the architectural guardrail is not one concept. It is a bunch of concepts, a bunch of layers essentially put together. So this layer, this concept that we're going to learn today is going to help your code base be more readable, not just for AI, but also for yourself as well. So I'll just give you a simple analogy. Let's say you have a garage door, and the garage door opens only with a garage door opener or a key. Now, I hope you have a secure place for this key, because if you lose the key, you can't open the door anymore, right? And so what you're probably going to do is
figure out a location where you can store this key. And so you'd probably put it in a drawer, maybe in your kitchen, maybe in your living room. And the reason why you're doing this is so that you can remember exactly where it is. Because you already use your brain to understand, to remember where this key is stored, you might probably also store other keys in there, right? Maybe your door could be like, hey, you know what? I already have my garage door key in here and I remember it. Might as well put all the other keys in here. That's how you be more efficient, right? There's no point in having 5 different locations. Instead, you would rather just have one spot that stores all keys in your room, in your house, and then you would just go to that place and then find the next key. And so that's essentially the exact same concept when we're talking about globalization. You want to figure out different parts of your code or your application that you can remove and globalize or set as a standard. And that standard should power up all the other features. Now, when we're talking about code, it's a slightly different part of your brain that actually helps decide what is reusable. And I'm going to try my best to help you understand here. So you have server, you have the client. Let's give it a different shape here. You have the client here, and you might have I think this is fine, right? On the client end, you might have other components too, right? You'll have pages, and then you might have specific components on the client side. And on the server, you're going to have some sort of function, right? Let's just say it's a function like this, fn. I think that's what a function is. So I break down my app this way. Now, other people have different strategies, obviously. I prefer this because it's so much easier to understand. I have the server-side code, and then I have the front-end type code. And so globalization now becomes easier for me. Now, I'm not talking about globalizing forms and components. That's not what I'm talking about. And I'll tell you exactly what I'm speaking about here, because I think you probably need to have an understanding of where I'm getting at. But imagine tiny little processes, right? For let's just take feature gates. If we're talking about feature gates, this is something that you need to put in your app so that it can be used across the entire app. Because this concept will probably need to be implemented on the function on the server level, and definitely inside the front end level as well, right? So what if a user is trying to access a page that they don't have, let's say they ran out of credits, and let's say their plan does not allow them to see this page. And so they shouldn't be allowed to see that page. And all other components that connect from this that are not on this component as well, they also need to have the same logic. So if you have a form that says submit or add project, for example, and their plan does not allow them to create more projects, that functionality needs to be reused, because if you don't reuse that functionality, then you have to recreate it here, a different version of it. You have to recreate it on the client side, and obviously for each of these components as well, right? So you might have a real web developer would probably do something like client side version, and they would do a server side version. And then later on, as you keep going, AI may not be able to differentiate. And so it might end up creating another client component level version. And so you see this creates code drift. And so here's a slightly different way to think about this. The client side version is nothing but just JavaScript. And so if I can take this section here and put that into a reusable helper. So let's say this just becomes a helper, which technically is the client-side version, but it's just assume it's a helper. Now, the same helper, which takes on the load of all of the complexity in deciding if the user has access to a feature, for example, based on some plans, right? That helper can be used server-side and client-side. You get what I'm saying? And these can have their own wrappers, and that's fine. It doesn't matter. So let's say if the server side needs to make a quick check before it actually uses the helper function, it can do that, no worries. But what we essentially just did here is we sort of extracted what we could reuse in the future, or reuse in different, think about it as it's like a plugin, right? You plug it into client components, you plug it into the page components. That's essentially what we're trying to do here. And that's the exact same concept that we're going to look at, which is the same feature gate concept, and show you how I built it into the architectural guardrail. So now this really sits, and you'll understand what I'm talking about. So in my app, the same functionality, the same thing that we're thinking about right now, which is feature gates, right? What I did was essentially broke that down into a client-side helper. And that client-side helper is a resource, okay? It's a resource map, and this resource map is a source of all truth across my entire application that helps me understand if a user's plan has access to a specific feature. And so let's take a quick look at that. So first of all, I have some source of truth plans here. And so I have something called plan keys that has free, starter, pro, enter, whatever I have. And I have this extra plan here called portal. So it's like a way to bypass all other internal payments. And I just created a map, sort of like a hard-coded TypeScript constructor, right? It creates the data set, it creates the structure of the data by using TypeScript, which is also kind of giving you a sneak peek into one of the other modules here, which is called TypeScript lock-in. But I'll just introduce it now itself because we already came across this topic. TypeScript lock-in essentially means that we are only using TypeScript as much as possible so that it throws those echo signals. So that's the first layer of the echo signal. The TypeScript essentially tells AI exactly what body to follow. And not just that, if you read this here, this is micro context injection. It gives this context to AI if it makes an error, if it uses the wrong plan name. What if, for example, what if later on it tries to use free like this, right? That would throw an error. You see everywhere, I see errors in the page. And that's exactly what we're trying to simulate here. So I have one page that essentially locks in all of the plans, and it creates the structure for each of these plans. But take a look at this, right? This is where it all kind of comes together. All right, so you guys ready? So this is the source of all truth called resources in my app. It essentially maps over all the plans and then creates permissions and whatnot, everything for that specific plan. So that's why I called it resources. So let's take a look at what that looks like. So inside resources, each topic here is a resource. Okay, so we have members, invitations, organization, roles, it's test stuff, obviously, but custom branding is a resource. For example, if you have a website builder, you'll probably have website or website pages, whatever that is, right? And let's take a look at the structure itself. First, we have the name of the resource. We have a description for the resource, and we also have an upgrade message for the resource. So what I've done is I've created a limit on the resource, and what is the limit I've defined here. And these naming conventions right here are locked to the same plans. And not just that, I also connected this to the navigation, right? And so it's kind of like settings. Think about it as settings for the entire app. If I change this right here, the entire app will change. So what I mean by that is, let me give you guys a more solid example. So my server here essentially has a couple checks it needs to do, right? So let's say the user is trying to create a project. Now, what I do first is I need to have the client-side helper, which is actually coming from the resources. And so what I do down here is I create these helper functions, right? We have helper functions down here that help with specific front-end tasks. So the first thing is it would check, does the user have access to the specific resource? So does the resource actually include in their plan? And how do we get the plan? That's another source of truth that I have that's happening somewhere else that essentially fetches the user's plan and stores it inside a cached, just think about it as a cached variable, okay? Just think about it that way. And so we have cached this variable somewhere in the app, and this data is readily available both on server and on the client. So the first check happens. So let's say user is trying to click this button here that says upgrade or create new product. What we're doing here is first we're checking if they have what resource they're trying to access. And then we use the helper functions that we created in here connected to the resource object, right? The same resource object that you see here. And this is happening on the client side. And then it checks on the free tier, the user is only allowed one. Do they have more? Have they already created more than one, or do they already have one already created? And we get that information from the cached usage, because when we fetch their plan details, the structure of that cache is also the same as this. And so that cache will have their plan and what they have consumed. And that's obviously cached on the front end. So now that we have that information, we can directly compare this And then we decide whether we can show a modal saying you need to upgrade. Now, here's the key. This is a reusable function, right? You can reuse this logic. It sounds like something that you can reuse. And so what I did was I extracted all of this, and all this functionality can happen just inside, just with the help of parameters inside a function. So if we have a function here, that function will require this piece of information, resource the user's trying to access, and the cached data, which is another piece of information that tells us what the user's plan is and how much of it they've already used. And then if something does not meet the criteria here, we just throw an error. That's it. And so this can be used on the server and on the client. And that's why I have the source of truth architecture being built into the app. And that's why, just as an example, if you see here, let me zoom in a little bit more so you guys can see. Inside the protected procedure, I have this thing called required permission. And you'll see the permissions that are being dragged in here from something called organization role. So in here, the user is trying to create a role, for example, right? And so let's just click into this and see what this permissions actually points to. Oh, it points to something called build permission constants. Let's click on that. Takes us straight to the resource entries. What's the resource entries? Exactly what we just built here. And so on the server and on the client, it enforces the same exact structure. And so you just have to change this in one place to affect the customer's usage. So that's why I'm trying to point out why globalized architecture is so important. So now in the future, when you're building something like this, I hope you keep this in mind, which is figure out a way to have this kind of structure so that way you can reuse the server logic and client logic in one place and have a source of truth so that it's easier for you to make changes. And that way you can plug those into the components. So don't tightly couple the logic of this with the logic of the server or client side, right? Keep them independent. But the part that we should be most interested in is the registry layer and how it connects to AI. And because it is a source of truth in our app, because AI ends up looking across our code, it ends up just kind of searching across our code, and then it finds these patterns, it will use the exact same thing that it sees in the other files. But here's the most important part. The goal is to restrict that requirement for AI to search and figure out what source of truth to use and then to use it. Because what I have done in here is by default, I've plugged it into our protected procedure, right? So AI does not have to think about this build permission system. It's already inside something else that is more commonly used across the entire app. So if there is something called protected procedure, this has all of the logic we just discussed inside it. And so I know that this is used more across the app. And so instead of telling it to figure out what it needs to use at a global level, I enforce the global pattern in something that's being used more frequently across the code base. And so it's easier for AI to figure out what means or what a source of truth architecture is, or a source of truth function to use to build the rest of your feature essentially. And one more thing I want to point out here, guys, I also have this permission thing in here, right? You can essentially implement, I mean, it's the same thing. I'm just expanding on just to show you what else I did. So for each of these plans or for each of these resources, I also have these permission kind of stuff. And what this does is for another team member, you can use the same permission gate and apply it to their role or apply it to their account. And so they can also create members, read, update, and delete. And if I don't want these resources on, or don't want these permissions on a specific resource, I just simply remove them. So for invitations, I don't want someone to have the ability to update an invitation. I'm just showing you as an example of what is possible when you think at a global scale, right? Not saying this is a 100% absolute best use case of this, but I'm just sharing. If you think about it this way, now you can remove certain permissions for features you don't want. You have as much flexibility as needed, but at the same time, the source of truth kind of instruction is followed across the app. And another, I guess, example would be, let's say the user has hit their limit on some sort of plan. and they try to, again, use the plan or use that specific resource, we can have an upgrade message, a globalized upgrade message for each of those resources in here. And I'm also using the sort of string interpolation. I think that's what it's called. I'm not entirely sure. But this kind of funky text, okay? And it does some sort of, it will change the text and kind of plug in the variable that it needs to plug in here. So the next plan is promoted from here, right? And so you see how this same thing can be reused across the app. And the same resources are also being constructed as the navigation gate, so the sidebar navigation gate. So on the sidebar, when the user refreshes the page, so let me give you an example here. So if I refresh this page here, you see, I see some elements here, right? These sidebar elements are also locked to the same feature gate, both client side and server side. So the enforcement happens everywhere. So even if AI makes a mistake, your code is still protected. I hope this is all making sense. And that brings us to the end of the globalization module. And since we already completed the registry module, I guess we can check that off as well. The next one is TypeScript lock-in. So let's jump in. So in this module, I want to deep dive a little bit more into TypeScript lock-in. It is a piece of the echo signal that is very important when building with AI. And so let's go ahead and jump straight right in. So the main reason as to why we're using TypeScript in the app, which I'm sure most web applications now are using, is not just to provide some sort of type intelligence or some sort of, okay, this is what it should look like. Not just that. It is to strictly enforce the code so much that it throws an error when AI tries to bundle or tries to build stuff. And this build is essentially just running an XJS build command and running any ESLints and stuff like that. So the first reason is source of truth. If you have TypeScript being enforced in your app, at all times, if you change something in the TypeScript structure, that will throw a linting error. And so you can catch not using a source of truth keyword or not using some sort of guidelines that you set early on. Now, for this to actually work, you need to implement this strategy right here, which is all TypeScript types should be dynamically generated. You can't hard code them over and over again. You can't rebuild the types. I've seen this happen, and AI actually makes this mistake. And the reason is because, first, you probably have bad patterns in the app, that you've been building so far. Or you just haven't instructed it to do so. And so please do. Okay, and I'll show you later how you can enforce these rules and instruct this to AI. But essentially, those types need to be dynamically generated. So here's an example. We already took a look at the permissions page. Actually, we took a look at the resource page, but this is the permission constructor. Just look at how this is set up. I know it looks super confusing, and to someone who is non-technical, this can be overwhelming, but most of you guys already have some web development experience, so you should understand this. Now, the key here is I did not sit and type every single thing out. The reason why this worked and the reason why this was created was because of my guidance, my direction. I directed AI as to how to create those types so that we get this source of truth type design so we can reuse that in the app more frequently. And it's also it's easy for me to understand and it's easy for AI to understand as well. And so just take a look at the permission constants. Right now, if you were to understand what is the structure of the permission object in my entire app, that's just a question for you. You would need to probably search every single piece of the code where I'm using permissions to understand, right? To understand what structure I'm using. But all I have to do is hover over this, and I can tell all the permissions I currently have in the app and the structure as well. Member_create is what the resource with the type of operation, a permission, and then derived permission. Like very straightforward. And so dynamically generating this means if I change something somewhere, like let's say you see this permission resource key, it already has a structure in place. If I went to this object, which is also dynamically generated from the resource key, which also comes from the key of type of resources, which is just using standard JavaScript stuff that extracts all of this. If I add something in here, if I say people, right, that throws an error. And so this is how TypeScript plays such an important role. It is not just, okay, I need to understand the type for this so I can provide code correctly when I'm coding. That's not the whole point here. The point is to make it so that the app will fail even if AI tries to put that piece of code in here. But the only way this works, like I said, is if you dynamically generate everything from day one. And so that also brings me to the next point. If you're dynamically generating something, that dynamically generated type needs to be strictly typed. That means you can't half-ass it, okay? You got to be as rock solid as possible. You have to make it so that type cannot be violated in any way. You can't use a K in all of these permissions keys, or something like unknown or any. You can't bypass those permissions. They need to be rock solid across the entire app. So you cannot use an unknown or any type inside and when I say any type, I hope you guys know what I'm talking about. Oop, the next one got revealed. Never mind. You can't use an any type essentially, right? You have to use rock solid types that already exist in the app. And that brings me to my next point, which is red-green prompting, which we will learn later on, but I just want to show you something here. You want to use types that already exist in the app, okay? And the reason why I mentioned this here is the thing I wanted to show you is when you're telling AI this, imagine I told AI, types already exist in the app. Use those types first. What is it assuming here? What is it assuming that exists? Well, it exists. It thinks that the type that was supposed to be built already exists in the app, and so it's gonna try to hunt for that first. That sort of bait and switch that we tricked AI into believing that something has already been created, and so most of the time something probably already has been created. I'm just not aware of it. I forgot about it. But by saying this, it ends up finding that type and it will connect that type and use it, right? And most importantly, when I say use those first, I'm actually being a little vague here because I can't write the whole thing here. We'll learn about this in the next few modules. But essentially what I do is I use Prisma as the source of truth type first. I use this type because it directly connects to my Prisma schema. And if you don't know what that is, it's the database schema. So if I have a user type, I will not create a user object, another user type object, and then start defining all the IDs, the user's name. This is not what I would do. What I would do instead is I would use the type that is generated from Prisma, and I would connect that type to this and expand on top of it if needed. Even then, I would not use this. And so my TypeScript instruction, or I don't think you need to instruct this, but you could just tell AI to always use the source of truth types that already exist in the app, and Prisma is the source of truth types that exist in the app. You should never create other types unless they are required for something globalized and are not already part of the Prisma schema. So I hope that is making sense. And so here's a quick challenge for you. The challenge is essentially, I'm going to try my best to give you a little hint, maybe a few hints, but I'm not going to give you the full answer. So when we build server actions, right? I think we use the term use server on all pages, right? And so just to see if you really understood this concept. Now this will take a little bit of research. It's not a straightforward answer. It's going to take you a little bit of finding, looking around. But let's say, not user, use server. This line typically is supposed to be mentioned in every page where you have server actions. And so I want you to create some sort of TypeScript or some sort of architectural guardrail that ensures that this line exists on these pages. So pause this video and try to guess or try to do some research to see how you could create your own architectural guardrail that enforces this concept. Okay? It's not the same thing as what we just explained, but it's very, very close. And so go ahead, pause this video and give it a shot, and then we'll see you on the other side. All right, welcome back. Hopefully you got the right answer. If not, no worries. Okay, I'm going to show you exactly what you need to do. So some of you might have thought, I'm going to enforce this inside the CLAUDE.md. Very straightforward. Tell the CLAUDE.md file to always have use server on top of the file, and this will probably work. However, I've noticed as my code drifted slowly, this AI just forgot about this. Why? Because the pattern in the app says something else. So I had a couple service pages that were kind of outdated, and they did not have this line on top of the file, right? And so what ended up happening is AI followed the same pattern, and it built multiple files, multiple services, and I went like for 20-30% of the app thinking it was actually enforcing that rule because I put it specifically inside the CLAUDE.md file. And so it's supposed to use it, right? But it did not. And the reason is because the patterns were incorrect. So no amount of context you give AI will actually work to enforce a rule. And so later on, I figure out the solution. And that's when, I literally introduced these concepts that make more sense to me, and which is not to rely on context only and to try to rely more on error logs and linting. And so here's how I would approach this problem. So I have an ESLint config file, and this config file will allow me to throw ESLint errors when something fails or when something is not following a pattern. And so the easiest way to enforce this was to create an extended object here that points to my service files and talk about this first line. So the first child is kind of like, I think this is sort of like CSS selectors. And so the first child should be server only. And this is a different different keyword, which we'll get to later. I didn't want to bring that up because it's different, and I have a dedicated module for that as well. But you see how now AI will look at this, and if it accidentally forgets to add the server only command or server only line at the top of the file, when the ESLint runs, it's going to throw an error. But that error will get plugged into AI, and so we'll know exactly what to do. Now, the coolest part is, while it's building, it will also find these errors. And because the pattern is also enforced, and we are also using micro context injection, so it'll get access to all this stuff. And so now it looks at this and says, okay, I need to have this on top of the file, and it will add it on top of the file. So there's a 100% guarantee that I will, okay, it's very difficult to say 100%, but I can confidently say that I will have server only on top of every single service file. I hope this is making sense as well. So that concludes our TypeScript lock-in module. Let's move on to the next stage now. So in this module, we're going to learn about normalizing identity. So in the real world, you're probably going to use some sort of third-party library to power up some features in your app. Some may use third-party libraries for authentication, for form builders, for whatever it is, right? And so the idea is is essentially this. First of all, I recommend you use third-party libraries. Don't try to build things from scratch, right? Because the more data AI has access to, the more consistent it can be with the outcome. And so, for example, if you try to build something from scratch, there's no documentation or external links that AI can use to refer to what is the best coding practices using those, the custom design, custom stuff you've built. And so my recommendation is to go with something that's third party. Because one, if it's widely used, there's so much data. Like, that's why I love Next.js. That's why I love using Clerk for authentication. I like using third-party libraries. I don't like building some sort of authentication from scratch or building a website builder type design from scratch. Now, I have done that in the past, and it just takes a lot of time, and you have to document really, really well in your code base. But the reason why I'm pointing this out is if you are a beginner, then definitely use third-party libraries. So now there's another problem that could happen, not all the time, but this problem could happen, where the third-party libraries you use might need to be swapped out in the future, or you sort of feel like if the third-party library was used in your app, it might be restricted to a feature that you need. You need something that that third-party tool can't give you, but you still want to use those tools. And so in my architectural guardrail, in the same boilerplate that I actually have two different setups. I have Better Auth, right, which I think is it's a paid plus, I think paid plus open source. So they have two different alternatives. If you don't really need the paid plan, but this is how Better Auth works. And then you have Clerk. And both of these have two different sort of offerings, right? Better Auth focuses on maximum flexibility and making it open source, but you don't get any sort of any of the things you get on the on Clerk. So Clerk focuses on speed and more on things like giving you audits, right? Session management, like all the stuff that you can do in a dashboard that you don't get with some open source tools. And so you just need to make you need to compromise on one or the other in order to get exactly what you want. But here's a better alternative. If you could build some sort of an adapter layer, right? It's an adapter layer that essentially connects to all of these. And that's why I'm calling this normalizing identity. Now, this will not always work. I love using Clerk for speed and because all the components are already built in and I can control sessions from the dashboard. And so I started with Clerk, but then there are some restrictions, obviously, on based on the tool you choose to use. And with Clerk, one of the things I wanted was role-based authentication because in funnelmods.ai, for example, you have the ability to add members, team members, right? So you can go and add team members in here, but Clerk only limits that to 10 roles in total. So each team member can have a role, but essentially if you create more than 10 roles in the entire application, you're done. You need to upgrade to even higher tiers, right? Which is fine with me. Like that makes total sense. But like I just want a little more flexibility there because my app relies on roles because I have something called customized roles. And so I need to create some sort of common layer that gives me a combination of Clerk, gives me a combination of BetterAuth, or some sort of, you don't even need BetterAuth here, right? Like it's not like, okay, I need to install this library and need to install this. That's not what I'm talking about. What I'm talking about is common things that you can extract from this. Again, goes back to our globalization strategy and sort of normalizing this, right? And we normalize this through an adapter so we can get access to those new extension features. So that's essentially what I did here. I'm going to show you what that looks like. So essentially what I did here, guys, is I have this adapter membership. And this adapter membership has a role property on this. And this gives us the ability to extend on top of Clerk. That means all Clerk does is it handles the authentication itself and the members in the account. But then I have this sort of role property in here and some other helpers in place that actually give it the permissions for that role. So if the user had a custom role, essentially, I'm not storing that on Clerk's end. What I've done instead is created this middle layer, which I call the adapter layer. And on that, I create a plugin type system. So whether I choose to use some other authentication or whatever type of authentication provider, it doesn't really matter because that role-based system, which is very easy to handle, is done with very little bit of code. Is done in here in this adapter layer. So now I can connect anything I want. So I love the fact that Clerk is fast. Clerk is easier to build with because it already has the components built out. So that's why I started with Clerk, and then I built this adapter layer because later on in the future, if I want to change my provider, I'm not locked in. So this is something that you can implement as well. And I guess this kind of combines our globalization module that we learned and also shows you how to kind of expand on some features that you're using from third-party libraries. I'll give you another example. So another tool that I have directly inside funnelmods.ai is it's a editor, right? It's a text editor, just so we can kind of see it as I'm building. This is a text editor. Now, you will see this looks very similar to Notion, right? This is exactly what Notion does. They have this kind of block style editor. I like this design. So I'm not going to build this from scratch because I know how long it's going to take for me to actually build all of these blocks, the components. Like I'll probably take forever, man. Like this feature will take me a very long time to build from scratch. And I also have to consider AI functionality. What if AI has to build into this text editor? And so what I did was I leveraged Lexical. So if you don't know what Lexical is another editor that works. And the reason why I went with Lexical is, first of all, it is open source, which is really good. But not just that, it has this kind of plugin type design, right? And because it has a plugin type design, I can essentially build my own extensions or my own adapter, right? My own adapter layer, and I can connect that into the Lexical editor. And another reason why I love Lexical here is because it renders server-side. So the same element that I was talking about, this editor, is rendered everywhere in my app. It's inside tickets, it's inside my website builder for a rich text editor, it's inside invoices section it's inside contracts. It's the same thing. So for example, you see I've expanded on this. So I've built my own plugins So I can expand on the baseline, right? So it's given me more features here. So I have a signature element. I have an input element as well. Where is that? Let's see. There you go, input field, so I can give it some properties here. And I also have dynamic variables. This is a very complex feature if you try to build it from scratch. And yes, this feature was built from scratch, but the point is it's easier to implement across the entire app because I've essentially consumed the plugin type architecture and built on top of the third-party library. So I have this sort of thing here where I can connect dynamic variables. So if I want to bring in first name, you see I can bring in a first name and connect a lead or a recipient onto this. This is a test recipient I've built, and that's why it plugs in their name. So if I do something like email, you see it's plugging in their email. So you essentially should consider using third-party tools to start from, and then try to build on top of what they have through some kind of adapter layer. So in my app, you see I have a shared adapter in here, and this is the shared permission thing. This is that adapter itself. And then I have different authentication providers. This branch is using Clerk only, and I have other providers like BetterAuth and some other third-party libraries, and I just have to create the adapter layer or the connection layers for them and just mirror that into the shared resource. So that brings us to the end of the normalization identity module. Let's move on now. So in this module, I want to discuss what this server-only concept means. Now, we already went across this in the previous modules, and so you understand how to implement an architectural guardrail to sort of control the use server-only, and building more stuff on top of this. But I just want to show you why I did this inside my application and inside the architectural guardrail. So this essentially connects to security, right? Everything in your app has to be as secure as possible. And when you're building with AI, AI can pretty much do whatever it wants. And so that's why I connect all of this to a pattern that has been used before, so it doesn't have to think. It just has to start implementing that pattern. And so one of the most common, I guess, security threats that I see in most AI developed applications is what it does is it creates this API endpoint, right? It has an API endpoint to essentially make any changes in the app. And then what it would do is inside all of these, it would create the authentication checker, like permissions, feature gates, etc. Now, we actually connect that into something called the block, which we'll look at later. But right now, what I want to focus your attention on is inside this API layer, essentially, for someone to call this API endpoint, they can just call the address. And so what some people do is they create a server action, which is very normal in Next.js applications, right? You create a server action that is a function and it does a very specific thing, which is it's just a function that can call the server. That's it, very straightforward. But what people don't understand is that server actions can also be called on the client. So if you have a form, and the form essentially has a submit button, if your server action connects to this, right, you can essentially fire this from the client itself. You don't have to run this on the server. That means server actions, I know the word is really misleading. What this actually means is it just does server stuff in here. But this function can be run on the client. So what that means is this function, the server action you created, is actually bundled. It's bundled on the client and it's sent to the client. So the client can now, technically speaking, a hacker just has to figure out the bundle ID. I think this is how you would do it. I did do an experiment a while ago to see how to find this, but you would probably need an ID of some sort, and you could literally call the exact server function. So if none of this is done in the server action, and you're relying on the API endpoint technically to do all this stuff, then the hacker can just bypass all permissions and call the server function directly, the server actions function. And so what's the smallest step of action that we can implement to completely eliminate this problem? Well, the first one we can do is to prevent this from being bundled onto client so that users, the hacker or whoever, can't actually call this function directly on the client. And the way to do that is by changing all server actions to server-only functions. And the way we do that is by importing this statement at the top of each service file. So if I show you what a service looks like, you'll see it has import server only on top. And the server only right here is what prevents this code from being bundled with the client. And nobody can call this endpoint essentially. This can only run on the server. That's what it means. So this kind of eliminates that problem. And now by building this pattern, we first instruct AI that it has to use this in all services. And we've also done the same thing on the ESLint config, if you remember. And so now it is strictly enforced for all these services to only be called on the server. And this makes this application so much more protected, so much more secure. And so that's why the architectural guardrail has this in place by default. So all services are protected. That means you can't call this function just like that, right? It runs only on the server. So that wraps up the server only module. Now is the fun stuff, which is the block. So let's move on. So in this module, we're going to focus on the heart of the entire architectural guardrail. That means the whole pattern recognition concept. All of the things we've learned so far kind of pieced together, because this is the bare bones. This is the skeletal structure for pattern recognition across our product, across our app. So let's jump straight right in. So this essentially combines the concept of globalization, obviously, and it also combines maximum security, okay? So it's super, super secure as much as possible. It also combines TypeScript as much as possible as well, and you'll see exactly why. And it also has some sort of normalized entry point, and pretty much all of the things we've just discussed, so far. So in my mind, when I was building the architectural guardrail, like I said, I was constantly facing this issue, right? I saw these things kind of happen. And so I thought, okay, if we are implementing some sort of globalized pattern for our feature gate system, then we can probably do something for the API layer, for the entire app itself, for the entire backend. And so this is what I broke down this whole image in my mind into. And so here are some things I had in mind when I wanted to build Mochi. And the architectural guardrail was derived from that. So the first thing is the app needs to be blazing fast. Like I wanted it to have some sort of optimistic approach, right? That means the user should feel like everything is just weirdly too fast, even switching between pages. Now, the first render is always pretty much depends on your speed of your network. So that I can't really control that. But for what I mean by blazing fast is optimistic approach, maybe some kind of server cache, right? Maybe client-side cache as well. We spoke about this, right? So having some sort of client-side cache, this is also important. And if I'm implementing optimistic, I need some kind of invalidation in place. So these are some concepts that I want to use in the app in order to create this user interface, this sort of user experience. Then the next thing I need is full TypeScript support. So this TypeScript support should be as easy as possible to also implement. That means by just building, I need TypeScript. I don't want to build TypeScript in order to create the TypeScript lock-in strategy, right? So that was something I had in mind as well. And the most important thing is we need that block type design. So what does this mean? So essentially the block is, imagine you're building this is the client, so this is the front end. You're building this feature. So this is what the user interacts with, right? All data, any and all data, whether it comes from the client, whether it comes from, let's actually change this name. I'm going to call this traffic because it just makes more sense. All kinds of traffic, whether it comes through a user interaction, whether it comes through someone just hacking the endpoint and directly calling it, or whether it is just AI building stuff. So even if it is just AI vibe coding and using these, using the API endpoint, or so essentially whatever is happening here, all sorts of traffic that needs to go to my backend, that needs to use my backend in some way, has to go through a block right here. It has to go through this block because I have a bunch of things I want to do before it actually hits the server, right? And I want to also have the ability to reuse some of these on the client as well, so I can create that optimistic, super fast experience. And so this block needs to have what all? Well, it needs to have some sort of session management, right? It probably needs to have the plan caching, so to check if the user has access to whatever they're trying to access. It needs to use our resources that we created, right? The source of truth thing that we created and I showed you a while ago. And it also has to have audit logs. It has to have some kind of permission checks, right? It has to have rate limiting. This just makes so much more sense because if I can wire all of this up into this, all of this stuff, sorry, the other way. If I can wire all of this stuff into this block that I was talking about, now whatever AI builds, if it can just use a pattern, and the way I create the pattern is by creating another easily referenceable kind of word. So I call this uh, protected route. Let's just call this protected route. If I could call this protected route, and all AI has to remember is protected route because it's been used so frequently, right? And we've created a pattern out of this, then my life would be so much easier. Whatever AI writes will end up going through here. Not just that, it also makes it easier for me to audit the code that AI wrote because all I have to see on my left sidebar is the git commit history or the git changes, and I should see a some sort of a resource if it's needed to be added or whatever. I should see the API endpoint, and I can click on that and immediately see if it used the protected route, and I'm all set. I'm happy now. All I have to do now is act like a QA and test the entire feature. Like literally click on the buttons and try to test outlier situations and see if the app is working. Because the code itself is built to production, like it's built securely. Now, when I say to production, I'm not saying that it's going to be 100% bug free. The thing is, bugs are solvable. You can solve these bugs. But what you can't solve is a breach that happens here. What you can't solve is someone's data, like let's say cross contamination, where you have an org, right? You have 3 orgs here, and they're storing customer data, right? But because you made a mistake on some layer here and you did not use org scoping, and what that essentially means is all data being fetched has to be scoped to this org. So it needs an org ID, right? And essentially, if this mistake took place, now you're in big trouble because now you have pretty much, you've breached uh, all security measures in your app, and now you've leaked customer data. And so let's say if this person accesses this person's data and this, or like that's when the mess up actually happens. And so it's not bugs that cause issues. It's actually these things that cause real issues in production grade apps. So bugs 100% solvable, and customers are very understanding with like, hey, this is annoying, please fix it. And if you fix it, they're happy, right? So that's why I wanted to point out that we need this kind of block layer in between. If we can build all of the most important annoying things into the block and give it a pointer to something that has already been built in the app as a pattern, AI just remembers that, and all it has to do is just build that. That's it. And then the TypeScript echo signals essentially tell it while it's using the protected route exactly what is needed to fully build out protected path. So we'll take a look at that as well. But some other concepts are that, well, it should plug into our existing, what existing stuff that we're building in the app. And then database isolation. So what I see people do a lot is if they're trying to use something like Supabase, right? What they would do is they would just use Supabase in the root of the application. That means they would use Supabase's IDE in order to connect to the database. So I think there's like a way you can create an instance with Supabase, right? Something like this. I don't know. I'm just giving an example. And then inside the app, they would start using Supabase to do supabase.get data, for example, right? Now, what if I want to change my database? What if the database is slow? What if I'm just not happy with my experience? And so you see, you've kind of screwed yourself over. And this is why I was talking about normalizing identity, right? Normalizing identity would have solved this problem. And an example is in Mochi when when I was using a database I did not want to use, changing it became hell because I did not build this in place. I did not put this in place. I didn't put the entire database isolation module in place. And so now I had to refactor all the code, but I was lucky because it happened early on when I started building. So it was easier for me to just strip it out. But if you had this from day one, if you ever face these issues, it's so much easier to kind of strip out. And it just costs you one line of code, or not even one line of code, maybe no code at all. And I'll show you what I did. So the first thing is to kind of bridge all of these pieces together, for database isolation, the first solution is Prisma. And I can't recommend Prisma enough. Like, Prisma is sort of the thing that makes this easier, this problem easier, okay? Because everything exists on Prisma. And so by using Prisma, I can now use Supabase. I can now use Neon, right? I can use pretty much most Postgres databases that I'd like. I prefer using Neon, and that's what Mochi's actually hosted on as well. I mean, that's what Mochi's using for the database. Supabase is all right. It's okay. I've had some incidents with Supabase in the past, but regardless, doesn't really matter. The point is, I can change now. I can change my database provider, and so normalizing identity is important. So that's the first thing, right? The second thing is, in my code base, where does my app access the database? Which file accesses the database? This is called a service. I call this a service because it just makes sense to me, okay? So it's sort of like a service in the app, and the service is the only thing that should connect to the database. So what did we learn so far? Service here connects to Prisma. We call a function on the service layer, and that service layer has Prisma inside it that actually calls a database. That's it, okay? So some sort of database isolation here is required. And so you see how all of these concepts that I just introduced, building it from scratch would take forever. And so that's why I'm using TRPC. TRPC is the secret sauce here that actually makes all of this possible. And let's go ahead and look at how I have split all of this up so it just makes more sense to me. So this block here that we just discussed, right, this block is a TRPC procedure. A TRPC procedure sort of acts like a middleware. Now, they do have something called middleware itself, and if I'm not wrong, I think we're using that under the hood, but the procedure is all you need to understand. So we have a procedure, we have the other stuff that's required here, which is the thing to call the database itself, which we just learned is a service layer. So let's bring that in. And then finally, we need the router layer, right? So the router gets hit first. The procedure is the block in between. And the service is the one that contacts the database. And it happens with the help of Prisma. Okay? So this is a linear path. So anything you try to build, try to map out a linear path. If you can see that pattern, then AI is most likely going to follow the same pattern as well. So let's look at code now, because this is the most important part. What does that actually look like? So let's take a look at this. So in the architectural guardrail, I have the TRPC folder, right? Inside here, we're just essentially creating or initializing TRPC. This doesn't really matter. It's just doing some boring stuff to create a server type caller as well. But regardless, here's the next thing. So we have this thing called routers here. This is the first layer, like I mentioned. And so the router here has this import layer that connects all of the routers. Very straightforward, easier to understand. It's sort of like a plugin architecture, remember? So it's sort of like plugging in cables, plugin architecture. And the same thing has been followed even for the same strategy here is followed even in the lexical editor as well. But you see, now I have all the routers. So what do the routers look like? Let's jump into them. So I think the member router would be good to kind of look across because it's easier to understand. All it does is it creates a TRPC router, straightforward. And then inside this TRPC router, we have list, all the different methods essentially. So I have update, I have delete. This process, remember I told you, I want a TypeScript to be created automatically. I don't want to build TypeScript, right? That automatically comes from this. So if I hover over member router, I know exactly what is required and exactly what's available on the server itself. So you see I have the CTX object, right? So all this stuff is kind of baked into this with the help of TRPC by default. So if you look at this now, every single API endpoint, list, update, delete, regardless, is using that protected procedure. Simple. So I know that when AI is trying to build any features into my app, as long as I see protected procedure in front of this, I am confident that to some degree this is protected, right? And let's take a look at what that looks like also. And this is a little more complex, guys. Just bear with me. Let's just quickly walk through this. Super simple. I'm not even going to explain anything. When you look at this, you're going to know exactly what's happening in here. Okay, ready? So the first thing is I've chained another auth procedure. That auth procedure gives me some options here, which is those cached things that we spoke about. If you remember, I told you that we're going to have some kind of server type cache. That is the CTX object that you see. And if you hover over it, you can see what data is stored in there. You have get organization, get active organization, the user, permissions, that kind of stuff. There's actually more in here, but I think that is stored on something else. I'm using this auth procedure in here just to expand on top of it. And just look at this. Point one, what's happening here? Just look at it without understanding the code, just read those comments. Request setup. This captures the start, right? And that essentially sets up the CTX object. What is org scoping? Onboarding gate, membership check, role gate, permission gate, path resolution. That means what exact resource are they trying to access? Then what's next? Per resource rate limiting, plan limit gates, feature flag gate, pagination, context enrichment, usage counter. This is a usage thing that just increments and decrements all of the customer's usage. So even whatever the user has consumed, that operation happens in here without you needing to think about it. And if you had to prompt this, imagine all of these things while you were prompting, you would have to tell AI to implement these features. So every time you prompt something like, I want to build a project listing page, don't forget you have to implement the audit logs, you have to implement, oh, that's also there too. I think we also have exception handlers, like any errors and what do you have to do with that. We have success, and we also have the log request. So save this as an audit log as well. So you would have to tell it to implement each of these things individually. And if you had them in different locations, you would either have to remember those things at least and tell AI to implement those. And AI has to remember those in order to do that. So this is why I have almost no context to understand this. Like, AI does not need a document folder to understand this concept. It just has to simply plug in protected procedure and forget about the rest, because TypeScript will throw errors telling it to follow the architectural guardrail or telling it to pass in those options required, such as permission gate or whatever resource they're trying to access. Okay, so now that we understood the procedure, which is kind of the heart of everything, and why all of this does not need so much context, let's just go one step behind to understand what does the router layer even do then. So the router layer is essentially the business logic. This is where AI will perform operations, for example, like how many pages can be rendered at once, or who can, maybe who is probably not the best example here. Let's say we're trying to build a website builder, and on the website builder, there can only be 3 members working on that page in real time. And if there's more than 3, we need to obviously reject, throw an error. So now that is business logic. That is logic that you want to control, which feels a little too specific to the site. So you put that in here, right? You can also put that on the front end to kind of speed up the process, but this happens on the server as well. And now, just as a quick experiment, if you remember the globalization strategy, since those two things are required on server and on client, you can create a helper and make that reusable. And now the same logic can be reused on the server and on the client, right? And if you have a cache layer in between, if you need this, you can use that as well. But regardless, you see how now the business logic happens in here. So let's say under the same example we were approaching before, which is how many people can access the site and collaborate together. It would do the filter there. It would check how many people are connected to the site. And then based on that, it would then make the necessary operation. So now in here, we're essentially listing all of the members, right? So let's move to where we actually get the data. All right, so I thought it would be better for me to show you a better example, and this is Mochi's code base itself. So I want to show you how I'm doing it in here for automations, for example, because this has a much better use case. The other one's just a boilerplate, but this one has some really rock solid foundation in here. So let's just take a quick look at this. So this is the endpoint. Essentially, it's the list router, and all we're doing is listing automations. Okay. And you see, this uses a different naming convention. I've used organization procedure in here because there's some other protected stuff that I wanted that does not need the organization ID to be plugged in by default. So here I'm using a different naming convention. It doesn't matter. It's still exactly the same as a protected procedure. But take a look at this. I have the input here set to a schema. And so what data needs to be passed in here goes through a ZOD schema. And so at all times, this will be accurate whether it is even if AI is using this on a different page and trying to consume this resource, it's going to be the exact same thing. So let's scroll down here, and you see right here we're essentially using that as the input. So if the wrong data is passed in here, or we forgot about something, or something is optional, then those echo signals will tell AI this is TypeScript essentially. And here we're returning a query. So if I have other business logic, that would happen on top of this. And then I would list the automations right here, which requires a database. But if you click on it, it goes into another page, which is a service. And this service has, import server only up top. So this service only runs on the server. But in here, all I'm doing is accessing the database. And this organization ID comes from the input right here, right? So you see how this is working. Essentially, we have separated the business logic from the database logic that creates that database isolation. Now, I want to share another concept that kind of makes this a little more rock solid, right? So you see how some of the API endpoints require org ID. And in the architectural guardrail, or in Mochi at least, sometimes this can be plugged in, and that's fine. You can pass this in manually. But now, in my app, I had a feature called Mochi AI. Now, my question to you is, how would Mochi AI essentially give this context to the LLM in order to make that call? So let's say I'm on a website right now, and I want to get all the components listed on this website that is inside my organization. How would Mochi AI know about the org ID? Does it have to guess? Does it have to think? Does it have to fetch the org ID? How does this work? Pause this video and just try to guess. And if you don't get the right answer, I'll show you exactly what to do. All right, welcome back. So hopefully you got the right answer. If not, no worries. This is exactly what you need to do. So the key is, like I said, to never let AI become creative and to do any thinking work. Make it so that either it uses a pattern or something has already been built that it just has to use, right? So you just tell it, use this and forget about everything else. That's the pattern you want to create. So to make Mochi AI work, this is a security breach, because if you told it to predict the org ID, what it would have to do is fetch the current website ID, and then it has to go fetch the org ID from there, and so call your endpoints, and then it's like, oh, I got the org ID, this is the org ID. What if I was just accessing somebody else's website? And so you've tricked AI into thinking you are on a different website and a different org, and so this creates cross-org contamination. So what do you do here? This org ID should never be plugged in, or never be essentially AI should never think about this org ID, okay? This should be dynamically injected into the call itself, and that's why I have the CTX object. And the CTX object essentially carries a session of the user who is currently logged in and currently actively working on something. And so with the help of this, AI can hallucinate as much as it wants to try to build a component into a website. Whatever it does, because I've injected this onto the back, not injected into the prompt, it's injected into the API endpoint. So even if the prompt has fetch from org ID XYZ, it's going to fetch from the correct org ID because it's injected into the API request itself. I hope this is making sense. And so the same strategy is also followed on all of the API endpoints. And the reason is because of this very concept. Okay? Because in the future, if you want to add some sort of AI agentic operations, like for example, right here, Mochi AI is super capable to doing things like creating a full marketing campaign, from building a form, building some sort of qualification on the form, questions for the form, attaching them to custom data, creating it on the site, making a nice website, and then attaching the form onto the site, and then creating automations in place to send emails, whatever that is. It can chain all of these. And the reason why it's able to do this is because we're org scoping by injecting it into the API endpoint dynamically, and we're not using AI to kind of predict that in the prompt. I hope this is making sense. So that's why those API endpoints have that CTX object that gives us that information. So that gets plugged directly into the Prisma schema or the Prisma calls. All right, so that was a beast of a module, but is the most important module in this entire course. And so far, if you found some value in what you're listening to, what you're watching, do consider subscribing. So that way, the next video shows up on your feed so you can learn even more stuff about this. I mean, this is what we do. This is literally what I'm doing every single day, which is putting all of my attention towards building better apps only using AI. And so if you are looking to learn these skills, then this is the best opportunity. So do subscribe. I think it also supports us as well, obviously, and gives me a reason to post more free stuff just like this. So we already went across the enforcement that you should make across the entire code base inside the block, which is part 11. But I just want to show you this a little bit more so this can kind of stick with you and you know exactly what I'm talking about, because this kind of pieces all of the things visually, right? So let's just go into this real quick, and we're going to go into the protected procedure. And right here, I wanted to show you point number 9. This plan limit gate is auto-derived from resources. So if you remember, we built this awesome source of truth type architecture, right? We built a source of truth keyword called resources. And those resources have a bunch of, it has a data structure that can be destructured in any way. So you can extract specific plans and the feature gates, the limits, etc. And you can forbid access based on those plans. So you see how creating that source of truth, that one single object, has helped us so much. We can check the limit of the resource. We can also check the feature gate, and we can throw errors in from one place. I didn't have to reconstruct this. So if I want to add a new feature in place, I go to the same source of truth word, which is resources, and I add in this new resource in there, and then I set up whatever I need, and it's like basic English, right? I just have to type out how much it has per plan, and then what are the permissions on it, and that's pretty much it. And that also has TypeScript. So if I forget about something, it throws an error. Now, I don't physically do this. All I'm saying is I could if I wanted to, but now when AI is trying to build the next resource, it doesn't have to think. I can spin up a brand new session, and it will automatically know about the context. So that's all I wanted to point out in here. We're essentially connecting our TypeScript that was dynamically generated, the source of truth resources, which is the plans that we created that has all of the permissions, the limits, the feature gates, and all sorts of stuff built into that. And then we're destructuring it in the way we prefer for each of these. So for each of these steps here, so we can use them, essentially throw errors if something has been violated. So that's pretty much it. So in most production apps, rate limiting is one of the most important thing. Now, we also went across this because it's inside the block, but I have this as a module here because there are a ton of people asking me, how do I do rate limiting? Or how do you control this with AI across the entire app? So let's just take a quick look and see what that looks like. So if you were to build this by yourself, I hope by now you can kind of map where you would go inside the code base to add this feature in. But rate limiting has to be done at the block level. However, different services might need a higher or lower rate limit. And so you have to have the customization layer on top of a base. And so I just want to show you what I have done. What I created here is another procedure called a base procedure. The word itself probably tells you what it does. And in here, it uses another middleware. And this middleware has the rate limit checker that's happening right here. And this middleware is what is connected into the protected procedure as well. So I don't want you to think that everything has to be built only inside the protected procedure. You have to understand the concept that I explained above, which is extracting and creating globalization and using globalization when possible. And so here I just extracted the rate limiting aspect and I put it into its own base procedure. Why? Because people might access my website a million times. That is also some sort of a DDoS attack. That is also something that requires rate limits, not just protected stuff. In fact, most rate limiting issues take place on public open resources. So that's why I have this right here. And what I'm using, guys, is or this is upstash rate limit essentially. And all it's doing is it takes in what is required, what limit I want, and it just passes it in here. That's pretty much it. And in order to do that, you also need, I believe, the client IP. So you have to get the client IP and then plug that in there. And, when you're developing, maybe I would say put an exception here because you'll constantly hit your limits. With TRPC, there's one problem. With TRPC on your local machine, when the bundle or the client bundle kind of renders, sometimes it spins up 100 times because I don't know, TRPC is just set up that way when you are using hot reload. But in production, you don't see that issue. But yeah, so that's how I would set up rate limiting in the app. And the reason why I'm showing you this is you can chain other procedures as well, but try your best to only have as limited resources as possible. That means one base procedure that does a bunch of stuff, and then one public procedure maybe, and then one protected procedure, and then chain them together. And since we're already at this, might as well kind of show you what the audit logs also looks like. It's pretty much the exact same concept, guys. So we're just done with the rate limiting concept. So for audit logs, it's essentially the same. We know the resource the user is trying to access. We know the customer, we know the member who's trying to access that specific resource. And we can leverage this and inject it or hard code it, essentially build this block in its own block inside the protected procedure directly. So whatever action the user does by default is already traced. AI does not have to create an audit log kind of line of code that specifically for each and every single router. And the client mirror essentially talks about the whole concept of pattern recognition. Imagine you did every single thing, you implemented every single concept we learned today in your code base or in the next project you're looking to build. That essentially creates a client mirror. That means your app essentially mirrors patterns, and AI will follow those patterns as much as possible. And so by using that concept in combination with globalization and pattern recognition, if you remember, there was a module where I explained how we can have a server and a client type functionality derived into a globalized function. So that way we create the sort of reusable interface, right? Some sort of reusable code. That's the client mirror. Okay, so those patterns end up being reused over and over again, which enforces the pattern even more. And then AI will use the same thing wherever it needs, on the server or on the client. So with that being said, we can check off all these modules here, 3 modules. Awesome. We're making some progress. Great job so far. If you're still watching this video, hats off to you. You're going to have a killer over time building some crazy cool applications. In this module, we're going to look at a gap in the architectural guardrail. So in our application, because we're using the block layer, this right here, the protected procedure, as the source of all truth, that means that all our security implementations go through this block layer. So if any parts of your application does not consume the block layer, it just violated every single security practice we put in place. And so that is terrible. That's horrible, right? We don't want that. And so I'm going to show you what could potentially cause this and how we can solve this problem as well. So in my app, I'm rendering these cards here, which are all of the plans for this software. Now I'm using Clerk here because Clerk building is just so much easier to set up, and it gives you the components built out. So these components are coming from Clerk. And the reason why I'm pointing this out is since it comes from a third-party provider, that is not going to go through our TRPC procedure. So the protected procedure is not being consumed in here. So I want you to pause this video and just try to guess, okay? Try to work this with me. How would you implement a fix for this so that all the Clerk stuff also kind of goes through that block layer? Pause this video and just try to guess. Okay, welcome back. So since these Clerk building components are being rendered using the Clerk component itself, it's not going to go through the architectural guardrail. So it's not going to go through our protected block, the protected procedure. So what this means is, for example, if some of the team members in here don't have access to the billings page. So if I give someone a specific type of permission and they don't have access to the billings page, first of all, our software, our app, already uses the resources, source of truth, to essentially determine if they should see this in the sidebar. Great. The service layer and essentially the router layer protects everything else from there. So the same thing happens on the server as well. So if anyone tries to access the billings page and any API request is made in there, that error will essentially throw because they don't have the permission to access that page, and it will kick them back to whatever dashboard or whatever page you want. But because it's not going through the TRPC procedure, anyone can just copy the link of the billings page and paste it and then directly access this because there's no other API calls happening on this page. So nothing's going through the TRPC procedure. So the solution is not to create another router or some sort of another procedure so you can pass in these components through that procedure. Instead, the simplest fix is just to have it on the layout. So on the layout.tsx, essentially, you can have a checker in there, some sort of a check that does all of the lookup. And I can see if I can show you some code as well. So one way I've implemented this is on the layout page. I'm not saying this is the best way. I'm sure you can improve this. But what I did in here is I used the same source of truth that we created earlier, which goes through the require permissions, if you remember the resources, right? I used the same thing, and I'm essentially using some sort of a header to understand, to just get permissions and stuff, or the path name, sorry. That's what we were using it for here. And based on the nav items, so on the resources object, I have the nav items. And so I can use that and kind of combine that with their permissions itself and understand if the user has access to this page or not. Now, you can run as many checks as you need, right? You can run as many checks as you need in here. But I thought this is decent enough because if someone's trying to access the dashboard page, already on the server, we're doing checks to see if they are logged in, if they have, all these things are happening. But it's just that those resources that don't go through the TRPC procedure need to throw an error. So maybe it would make sense to put this at the adapter layer. You could probably put it there too. But I just put it at the layout location. I put it on the layout page itself. So that way, if I have other sort of third-party tools that don't go through an adapter, I don't have to care about it. But I'm sure there are better ways to do this. But I just wanted to point this out so you can implement something like this in your application as well. All right, let's go ahead and strike this out too. We're done with that module. And the next one is, I think, one of the most important modules in this entire course. So I'll see you in that one. So in this module, we're going to learn about inline injection, which is a strategy I created that helps with micro context injection, delivering tiny pieces of context to AI at the time it needs it, instead of dumping huge documentation files and folders to help it understand before it starts implementing. So let's jump straight right into this. So the whole point of the architectural guardrail is to enforce source of truth architecture. When you know where something can or will be in your app, it's easier for you to route the entire app. But if there is part A and part B, and these two are supposed to connect in some way at the context level, how can AI know this at the time it's reading that piece of code? Well, we could technically create a doc folder and we could have files in here that directly feed context to it. So how does the architecture work? Or how does invalidation, right? How does invalidation work, for example? We could feed this through external documentation, but this means all of the context of this file needs to be injected into the context window. Instead, all I do is on top of every block of code, I follow an inline comment. That's it. That's all you need to do. So this small little change makes such a big difference in your context consumption. Now, I'm not saying that if you use a $5 plan, you're going to get the same token consumption limit of a $200 plan. That's not what I'm trying to say here. All I'm saying is you can drastically probably cut all of your context, most of your context window, just by this small little tweak in here. Because now what AI does instead is initially you will give it a path. And I'll show you what this looks like in the next module because that's equally as important. But when it starts, you're going to give it a path to follow. You're going to give it a path so it knows exactly where to look. And then when it starts looking into that path, you then eventually guide it with inline documentation. And each of these inline comments use a what, why, and how, or sorry, what, why, how, and where pattern. And so these questions here are answered inside the inline comment. Now, you're not supposed to add this in every single line of code, but I mean, you could if you want to, but then the code just looks horrible. Like, I don't like looking at it. By the way, this is not to make it really good for web developers to code on Teams. That's not the point of this. This is to make this architectural guardrail is to make AI development as easy as possible, making it easy for AI. Okay, so in the real world, we technically do not like to do this. Like, we don't write documentation on top of every single line of code or every block of code. We prefer to write it maybe at the top or as high as possible. But when it comes to building with AI, it's all right to use in between every single line of code if needed. But I always prefer to still follow at the top, follow the inline comments at the top of that function, at the top of a block. So if it's trying to understand what this block of code does, just by telling it what, where, why, how, just answering these questions, it knows how these two different concepts connect to each other. And just to be clear, guys, because I know I said I don't like to use a docs folder, but you see a docs folder in here, so you might question it as to why do you have all this stuff? You just said don't use it. This is actually for my members in my community so they can learn about how everything works. So this is client facing, and when I say client member facing, this is not to document the architecture for AI. Does it use it? No. And I'll tell you why it does not use it. The reason why it does not use this is just based on my experience. So in the past, when I was building Mochi, at one point, I had this really bad architecture when I first started, and I was trying to use the docs folder to guide it. And eventually, I wanted to strip out the entire architecture. And so I did strip out the entire architecture and I moved to something new. That docs folder was outdated and it was there all the way until the last month, the last release month for Mochi. And so that clearly means that it does not care about your docs folder. It, in spite of having outdated, incorrect docs, it still followed the right implementation. It still followed the right architecture. And so it means the inline comments outperform the documentation files in the documentation folder itself. So just delete it. You don't need it. I could delete it right now and it'll work absolutely fine because you can just see all the concepts we put in place, right? And these concepts don't rely on context only. It relies mainly on those linting and TypeScript and error handling. That's how AI kind of navigates itself and figures out what's correct. Okay, so now we just learned how to provide context to AI through inline injection. But now, how does AI actually find those files? How does it find the location to kind of ingest all of that context? And that's the next module, which is the Grep-first module. So let's just take a quick look at that. Now, here's the single biggest change you can make right now, this very second, to almost like half your context consumption. And my guarantee is I can't guarantee, but I'm just saying, you might be able to drop your subscription from $200 to $100 per month. So by watching this video, I hope I helped you accomplish this, okay? And this is what you have to do. So the way AI reads your code base is it has no idea of what you're actually showing or what you're trying to build. Like, it doesn't know what your code base is, right? And the way it understands is by reading a few files, and it starts with a linear pattern. So it looks at the folder structure and it understands, okay, this guy has this app, and what else does he have? And then it looks at TRPC, and then eventually it sort of navigates its way. So AI is blind. It has no idea of what you're essentially trying to ask it. And so if I could, in some way, point AI in the right direction as fast as possible with zero context consumption, until it actually needs to read the context, I'm sure my context window is not going to be flooded with useless documentation. Because right now, probably in most people's code bases, AI would need to read the docs folder, which is already consuming maybe not 90%, but maybe like 20%, right? 20, 30%. It's already consuming. It's consuming something, right? There's so many files in here and it has to remember all of this stuff. And so it'll probably fill up small percentage with that context window. But if I could remove this and point it in the right direction first, saying maybe here or here, like if I could show a list of where it could look at first, I can drastically reduce my context consumption. And so the way I do this is with the help of a grep script. Okay, I'm going to show you exactly what you need to do, and I'll show you how you can enforce it in the next module as well. So the way this works, let's just open up the terminal and let's do this, and I'll show you what that looks like. So if I was AI and I wanted to find the file where the source of truth permissions architecture exists, or something along the lines of that, right? I would probably need to open up the folder structure, and I would need to first search for those files or search for something called permissions. Now, on my first glimpse, I'm probably not going to be able to find it. Okay, I found something here. There you go. So I found permissions index.typescript, and this was the file I needed, right? But it took me some time to find this file. But how did I find this file? Well, I looked at procedures here, and then I understood index, and then I went into that file. Sorry, not procedures, guys. I went to permissions, and then I found the right file. But sometimes we might have the permission file here, and the source of truth may not be in this file. It might be in something else. And so now, how do we enforce source of truth architecture with this new way of actually finding that exact location? And so the first thing you need to do before we get to grep-script is SOT keywords. So write this down, source of truth keywords. And so what you're going to do is when you're documenting this, and we don't document this by hand, this is actually part of the next module, or I think the next couple modules, which is handling the CLAUDE.md correctly. So we'll get to that in a second. But we will essentially write a source of truth keyword section up top here inside the inline documentation. And then we would write as many keywords as we can think of, not too many, but just enough. And some of them pointing directly to the location where the source of truth exists. So this is the place where this exists, right? And so now, if AI was trying to find patterns in the app, it could search for these words and find them instantly. But here's how I've enforced this so that it does not need to read context in order to find the locations first. So the example that I'm going to show you here is just to find the source of truth keyword inside permissions, for example. So the way this works, guys, is through a grep script. And I've enforced this on the CLAUDE.md file, inside the CLAUDE.md file, by telling it to first use a grep script to find a list of the files that are worth looking into. And so now if I hit enter, look at my context. This is all that gets injected into my context window. And now, based on what you see here, you can filter from this even further. And so now I'd run something like this. And now this gave me 4 files where the source of truth source of truth keyword for permissions exists in Prisma, and permissions.index. Boom. Now I click right into this page. I'm inside the source of truth architecture for permissions. This is the coolest thing I came up with. And the way I figured this out is when I saw once I saw how Claude was actually finding files and finding locations, and I was like, why don't I just enforce this as the first step? Because it would try to search for a concept, and then if it didn't have access to, or it didn't have knowledge of that concept, then it would try to figure out in all the files that kind of scatter across. And what it did was it dumped all of the context of those files into the context window to read. And so instead I was like, you know what, I'm just going to reverse it and tell it to first narrow down based on files and then search deeper based on where it thinks is the best fit or where it's actually going to be. And so that brings us to the end of the grep-script module as well. Great job on coming so far. Now we have to take a look at the CLAUDE.md. So let's jump straight right into that. All right, so now is the orchestrator, the main thing that connects all of the concepts we've just learned so far. This is the CLAUDE.md file. So here is my CLAUDE.md, and the first thing you'll notice is it's only 86 lines long, all right? And in my Mochi's code base, it was only 25 or 26 lines long. And so that goes to say that you don't even need so much. I just over explained some stuff, and I feel like some of the things are not even, going into context correctly. So I might change those later. But anyway, this is what you have to do in order to set up a Claude file. So I like to create a folder. That way I can create a CLAUDE.md inside that folder, and I can have settings, and I can also have skills and agents if I want to create them in the future. Not saying that skills and agents, I know that I said you don't need them. That doesn't mean they're bad. They are awesome, actually. And I do have a lot of things in here that I want to move to a skill or to an agent. But what I feel is what I want to show you is that this will work regardless. And this is just proof. It's proof of concept that you don't need a different sort of workflow. You don't need a unique, you don't need a unique workflow that looks all crazy with 500 agents. All you need is a good architecture that follows exactly the same principles that we discussed today. And of course, all of the other prompting strategies that you're going to learn next. So if you look at my Claude.md, like I said, it is 86 lines long, and my Mochi's code base was 26 or 25 lines long. So you don't even need to type this much, okay? I just did this because I'm just kind of experimenting on different things. So let's take a look at this. The first one is the pattern recognition system. So essentially, I tell it everything you're building in this app is from a pattern recognition model. So you should never invent your own architecture. You should always essentially verify that the pattern already exists in the code base, or else just don't use it, right? So you can't pull in your own libraries, and you can't start a new pattern first without confirming it does exist. So the app runs on a source of truth global architecture. That's the next thing here, which is already established in the app. Now, you might be wondering why I said this, and you'll learn in the next couple modules. I'll walk you through that as well. This is a very important concept, and it is the single biggest leverage you have when you're prompting. Next, your job is to build into it. So never create your own stuff, right? Globalize what you write, so the app stays modular, and future features are plug-in rather than rewrite. Okay, so nothing should be tightly coupled. I actually removed this line. I forgot to change it. Oh yeah, you see, I just updated it. I got to change that. And swapping tech stacks, etc. All of this should be easy. The next one is don't create blindly. Again, you see, I repetitively, I keep telling the same concepts over and over again, and I feel like that sticks with AI more. And in the prompting lesson, you'll also see maybe one. I have one more concept. I don't think it's rock solid. It's just a thesis that I have, or just a theory that I have. So I'll show you what that looks like too. But here I just say only when existing architecture can support the new features should you build something new. So the next one is the grep script. This is essentially what I was talking about, right? So the whole code base has a source of truth keyword and a line at the top of each file. If you remember, these keywords are the fastest way to reach that piece of code. And so this is what keeps context pollution at 0 and stops us from burning through session limits. And so I think I also mentioned you should prioritize this, but I just updated this. But you could tell AI that your goal is to prioritize session limits as much as possible and lower token consumption as much as possible. You can say that. Quite literally, just say it. It will do so to some degree, right? Next, before creating any type functions, constants, or components, grep for it first using L. This is the key here, because if you don't use this, and if you use RN, I think that's the wrong one. Yep. If you use RN, you'll end up getting all of the file context for all those files, and it'll get dumped into the context window. That is horrible. We don't want that. It's the fastest path to find what you want. Next, when you're creating something new, add the keywords. Next, don't create duplicate functions. And I actually added a line here that it got removed. The line is, I have already created all types. If you search for them, you will most likely find them. We'll get to this later, and I'll tell you what's the trick here. The next one is the layered architecture. So I'm just explaining, like, this is the only small piece of technical knowledge, and even that is not like how to construct the protected layers, like none of that. What is a protected procedure? What is a router? What is a service layer? And it's more of what instructions it needs to use it needs to consider when using these. So I just said every important router endpoint needs to use this. Straightforward. Routers. They consume the protected procedure and hold business logic, validation, orchestration decisions, etc. That's it. Service layer is the only thing that touches the database directly. And so this needs to be at the top of the file. Technically, I mentioned it in here as well. I don't think it would need to have this in here because I don't think I would need to have this in here because we already have the linting check. And not just that, we also have a a pattern, right? All the files already have this, but it's good to always mention it. It's one line, so that's fine. Remember to wire up permissions the feature requires. This is important because I've already wired up the permission system into the architectural guardrail. So this is required for me. Next is I know that Next.js changed the middleware to proxy. For some reason, this was like the worst change ever made. Even though it was a good change, but it was the worst change for AI because AI does not have enough data to understand what the middleware file is and what the proxy file is. So I just put it in here to avoid all. Now comes the TypeScript part. My first rule is you should never use any or unknown types. You can never hardcode types or use other TypeScript bypass commands. So at all times, I've essentially made this as rock solid as possible, right? And it has to always use some sort of TypeScript that exists or dynamically generates something. And I've mentioned that somewhere in here. So you see dynamic TypeScript is the only types you can use. And Prisma types is the source of all truth. And I just pointed at the types folder because what it would do is it would create the type in the file. And it's not a bad, I mean, it is a bad coding practice, but you will see a lot of production projects sometimes doing that, which is just creating the type for that specific code in the same file. It's just like when they think about it, right? It's like your team works on this stuff, and so you don't need to see somebody else's types. So that's how they think about it. I don't like that approach. I like to have everything in this libs file. Why? Because it makes AI's life easier. So that's what I did. I put this in here. Then validating. So I'm using Zod, and I prefer Zod because it throws errors, right? If something's not right, it throws an error. And so I'm using Zod here to validate all inputs. And in the inline, so this part here is inline context injection, very straightforward. This is repetitive. Like I said, I just changed this and reduced it a little bit because I had a lot of repetitive concepts in there. So I also gave it the structure as to how to comment. And the next one is UI. So this is something I introduced recently, which was a UI type helper. So how to create components. And a lot of you were wondering, how do you create good components? Or, well, it's not specifically for design. For design, I have a different process, and that's a whole different video. But this is specifically towards how to create components from an architectural standpoint. So the idea is the same, globalized architecture. When you're creating components, if it can be globalized to some degree, globalize the component, right? That's the idea. So check whether a reusable one exists first and use it if so. Never duplicate a component with similar functionality. Extend or compose what's there. If you notice yourself copying a pattern of another component, that's a signal to globalize it instead. This kind of helped because I was afraid that AI would just see one pattern and only see it twice and then create a new component out of that. It didn't do it that way. Like what it did instead was it saw places in the app where it could potentially create a component out of that and add some functionality. And it did some really cool stuff. So in Mochi, let me see if I can show you. Okay, so take a look at this. This is Mochi, obviously, and you'll see I have a header component in here. Now, this header component is the same thing used across the entire application, right? You see, it looks very similar, but you'll see some differences. You can see sometimes they don't have buttons here. Sometimes there are different sizes, like something looks different. And the reason is because we created a slot type architecture. So this is something you'd see in Figma. And the way it works is this block right here, this section is a slot. That means you can push up a component into this section. And you can do so by passing it as a prop, right? Or right now, you won't be able to pass this as a prop. I think what we're doing here is we're passing the prop back up. This is very standard, React practices. And so we are passing the component from the childs all the way up into this header component and then passing it in there. So this way you can have custom functionality in the nav bar. And that's why my dashboard right here has this cool AI generated dashboard, and it has this button here where I can tweak, change between. And I have dates, etc., whatever, and you can change it directly from here. It already comes built in with responsive design. It also has the light mode, dark mode, whatever you need. So it just makes our life easier. So it kind of built that component because it saw it using it more often, and I had to nudge it. Obviously, I had to tell it, give it some guiding, some guidance as to how to create the slot. But let's move on. So right here, I have a global folder, and how I differentiate components is just like this. If a component is global, put it inside the global folder. Do you need to put in the global folder? And why not just in the components? Doesn't matter. I don't care. I understand this when I read global component inside global means global component, right? So AI understands that better as well. The next one, if the component is only for a route, then I just put it inside the route and underscore components folder. This is a Next.js practice, the common Next.js practice. You'll see it on my videos and everybody's videos online. And I prefer this as well. I've seen this in industry grade, applications as well. So next is design every component for reuse. So this is where I essentially tell it to not hard code any logic, and whatever component you are building, just make sure I can reuse it to some degree, because that's why we're creating components in the first place. Makes total sense. Cool. Simple new component, follow the design themes already in the app. So designing is a whole different thing, guys, but maybe we can have another course in that. But if you look at most of my applications, they look nice. And the reason why they look nice is because I don't like to give AI full creativity. I give it some direction, and we'll get to that later. Just let me know in the comments below if that's something you guys value. So the next most important part, I'll give you one design kind of hack here. Essentially, I do not like to hard code any types. So text white should not be used. So never hard code any values. Instead, use all of the tokens that Tailwind CSS already comes with. The reason is because if you change your globals.css file, the design changes accordingly. And so it just makes your life easier. If you hard code types, then light and dark mode will not work anymore. And so that's why I have this very important rule here. This makes my life so much easier. Next, delivery. Before you hand over, I think I also want to point one more thing, guys. In the TypeScript section, it needs to run a TypeScript check every single time it hands over something over to me. So that's important. And I'm using barrel exports here. This is not a good development practice in production grade code bases, in the sense that if you're typing out code by yourself and you are going to be the one reading the code, then I don't usually use barrel exports because it's just overwhelming. You have all these files being imported, and I'm not sure I'm not sure how it bundles correctly. So maybe you want to check that out as well. But the reason why I'm using bundle exports here is because when AI can find an index file, it will find everything else from there just like that. So let's say I'm building a website builder and it wants to map out how the website builder works. Inside my index file, I essentially, inside the barrel exports in the file, you can see every single section. So it says reusable components, custom built sections, or toolbar, etc. So AI knows how to connect the dots. So that index file gives it all the context it needs. That's why I have it set up this way. And so this just makes it easier for AI to understand, not for humans, okay? Because sometimes you'll have a full file just dumped with all these exports, but it just makes AI's life easier. Never skip a feature or leave it incomplete. This is very important because sometimes AI will think it's building something in the future, and it will leave a small piece which has complexity incomplete. And ask you for next steps. And that's something I prevented by saying this. And actually, I've reduced this just now. And so that's why it's removed some of the context. But essentially, what I used to tell it is more detail, right? Which is I would tell it to essentially finish the full feature, completely start to finish, and then also send me a screenshot that it works. And I use something like Playwright MCP. So we'll get to that. That's, again, design related, QA related. We'll get to that maybe in a different video. And most importantly, this is the most important command. And I've also mentioned this to you guys in the first module, which is the mindset module. Never let AI use Git. And I have a rule in here because the number of times it has messed with my Git file and just changed a bunch of stuff is brutal. So never let AI use Git. Okay. So that brings us to the end of our Claude.md file. That's it. That's the Claude.md. And so now we can move on to this section right here. All right, so now that you have implemented all of the strategies I just explained, you've wired it up into your code base, you set up the Claude.md, this is where you will see your session window kind of free up a little bit more. And this is where members, usually people who are testing out their architectural guardrail, start dropping their subscription from the $200 per month plan to the $100 per month plan. By the way, I just want to make one thing very clear. Hitting your session window is not a negative thing. It's not a bad thing. If anything, it means that you're using what you paid for, right? If you paid in excess for something, you want to use all of that. And so hitting your session limit in spite of all of these concepts in place is not a negative thing. It just means that you're probably getting 5, 6x the output of someone else. I mean, think about every single concept, every single layer that you've added into your AI development workflow. There's no way on earth there's no way on earth your code base is going to be worse than what it was before, right? You've put all industry grade practices in place. So yeah, don't take it as a bad thing, if as a negative thing, if you're still hitting your session limits. I'd say hit your session limits on top of everything we've just put in place. All right, so let's go ahead and strike through. Boom, awesome. And now let's move on to the most important module in this course. In this module, we're going to learn about prompting, which is the most important thing in building with AI, because if you don't know what to tell AI, then AI is not going to know what you want. So now you'll be very surprised because this is very simple. It's not as complex as you thought. And the reason is simply because we have put all these layers in place already. We have all of this, the entire architectural guardrail set up with the system, the Claude.md, everything is connected. And so by now, your prompts should shorten by at least 40, 50, or even 60%, because you don't have to think about the auth guardrails. You don't have to think about the permission system. You don't have to think about feature gates. You can just only focus on your feature. I mean, if you paid attention to the testimonials from members who have actually tested the architectural guardrail, they'll tell you the same thing as well. You can see Damien said the exact same thing. The only reason why he was able to focus on the app was because the system came with everything inbuilt. And so he didn't have to prompt with all of those in place. So with that being said, there are some important concepts we need to cover because these are kind of like hacks, okay? So let's take a look at all of this. So when you're prompting, there are two types of features typically. You have complex and you have simple, right? Prompting a simple feature, because you have the architectural guardrail in place, is as simple as just typing plain English. Don't think about this too much. And I know you're wondering, that's exactly what I've been doing so far. Trust me, when you have this in place, when you have this in your code base, you will notice that even features that are on the spectrum right here, right, on this gradient right here, even if it's right in between, or even if it's sort of complex, you can still one-shot them in plain English. You will be surprised how good the architectural guardrail is, right? So if it's a simple feature, just one-shot it in plain English. And here's how you should create the prompt. Your prompt should consist of the big feature you're trying to build, so big feature, and then all the small features, okay? And since it's something that is simple, I don't think these small features are features of its own self. Like for example, in my app, I had this one feature called lead lists that I one-shotted, right? And lead, the way it works is you can essentially create a reusable filter, and that creates a list. So you have a list from here, and this list can then be dropped into an automation builder. So you can drop it into an automation run. That's what I mean. So this feature by itself can be one-shotted, but this cannot, right? And this feature looks to be a part of this feature that you have in mind. And so at the surface level, you're thinking, since automations are part of this big feature I'm trying to have, which is lead lists, I made a spelling error here. You might think of one-shotting this, but that's not what I'm saying. What I am saying is a simple feature is a feature of itself, and the small features are just tiny little things inside of that, okay? So things like creating the filter button, adding, moving leads between, a move button to move leads between the list, or delete a list. Those are small features. A complex, like if you ask me, an automation builder is a complex feature, right? So always try to break down whatever feature, whether it's simple or complex, into tinier little chunks and iterate. The best way to build software with AI right now, I don't think this will be the future, but for now, is an iterative process. There are so many workflows that you can put in place that can automate all of these, and you just let it code while you sleep. But that's for a whole different video. We don't have to care about that for now. This is just how to use the architectural guardrail. So that's what I would focus on. Taking a simple feature, breaking it down into smaller, tiny little chunks, and then approaching each and every one of them. But if the feature is pretty small, then I would just one-shot the whole thing, okay? Now, how do you approach a complex feature? So a complex feature is, I would say, I'll give you one example. This is the most complex feature I have built only using AI. And so this is the website builder, right? And I don't think anybody can build a website builder because it does take technical expertise, something you have because you're a web developer. So the way I would break down a website builder's prompt is slightly different. First of all, we have to take the same concepts we learned from the simple prompt approach, which is not modular. It's supposed to be iterative. So how many features are features of themselves inside the website builder? The canvas, we have drag and drop, we have frames, we have style sheets, or maybe not style sheets. What do you call that? I guess styles. Well, let's just call it styles, right? So you have all of these that technically fall under the website builder, but this in and of itself is a feature. By itself is a feature. The canvas is a feature by itself. So I would break this down into a list like this, which is the tinier things that I need to have. Then I might have something like components. So pre-built components, right? Things like payment forms, calendars, etc. And now, how would I approach this? So let's say pre-built components, I have a calendar. I'm just showing you how you should actually think. So the idea here, guys, is essentially to create a prerequisite chart or a linear workflow. So number these in a linear workflow so that all prerequisites are fulfilled before the actual feature is being built. So if you look at this, just challenge yourself, right? Ask yourself, if my website builder was to render calendars, for example, right? That's a pre-built component. The goal of the website builder is to render pre-built components. Pause this video and try to guess what would be the pattern or how would you approach this feature. Okay, pause this video and just number these down from 1 to 5. Which one goes first and which one goes last? All right, welcome back. Hopefully you got the right answer. If not, no worries. So since we're building this website builder, obviously the first feature would be the canvas. That's what everybody would think. But that's not actually the feature you need to build first. It's actually components, the calendar. Now, not components, I mean the calendar section. So we'll remove this real quick. The task was you're trying to build a calendar so it can render on the site, right? So what I would actually do is I would finish building calendars in my app first. And I do have calendars in my app. So this is localhost, but you see down here, I have calendars. And what I would do, guys, is I would first build the booking calendar first. So this is the booking calendar, right? So I'd build this first. That way I can, I have this ready to go when this feature needs to be built. So this is what I would approach first. Once this is done, now it's time to move on to the next. So first I would do canvas, then I would do frames, then I would do drag and drop and style. So let's just quickly rearrange these. So let's put this right here. 2, 3, 4, 5. There we go. So this is the order in which I would build. So now we understood the linear order. the order in which we're going to start prompting. And now we need to start prompting. So for the calendars feature, we will leave this for now. Let's just assume we already built it because we're trying to focus more on the website builder. So for the canvas, what do I need? So remember, our first approach is global. We're thinking at a global scale, globalization, right? We're thinking as to build something that can be reused across the entire thing here. So when I look at this, the first thing that comes to my mind is architecture. And that's actually what we have to focus on first. Architecture for all of this to work. And the architecture for this is, first, state management. So how can you manage, how can you store the state? Then how can you mutate the state? So updating the state, that's essentially what we'll need to think about. And also the structure of the state. This is also equally as important. So let's move this up here because this might be important later on so you guys can kind of see this. So for state management, I know I need to have some sort of Redux state. And I'm using Redux because it's just what I've been using in all of my production projects and even at the companies I've worked at in the past. So Redux just makes a lot more sense to me. So I would use Redux. And then for mutating, I'll think about that next. And then the structure is probably what I need to think about next. So you see, again, we're creating another linear path here. So we have mutation, then we have structure and state management. But first, the structure would go first. Then we'll think about state management and how we'll store that, how we can move data from the website builder into that state. And then how can we change or update that state? So I'll have the Redux website builder or the Redux structure. And now I'll think as to what that should look like. Now there's two ways. And this is where your technical expertise as a web developer comes in play. And what I would like to do here is I would think of what do I want to store here? Am I going to store a website or am I going to store multiple websites? All right. Now, depending on, so if you typically, I think in the real world, again, this is something you might want to test, but I think storing multiple websites, more than 2, 3, 4 websites can be very expensive because you might run out of, I don't know if it uses RAM, but you're going to run out of temporary storage, right? I'm not talking about local storage. What I'm talking about is in-app RAM, right? In-app memory, essentially. You're going to run out of memory because you're going to store so much data inside the Redux store. So what I would do instead is maybe have a 2 website storage system, right? So users might probably only be building 2 websites at a time. So 2 websites sounds good. So what does that mean? My structure would look this way. Website 1, website 2, and this is the Redux store. Now in here, I would need to have all the different fields. I'll have the ID to represent that. I'll also need to have the org so we can scope the website to the org. And then I would also need to have the website data, right? So data. So this is how I would create the structure. So now, just as an example, we have built a structure. And I would like to think of every possible way to include all these features inside that structure itself, inside that data structure. So now when I break this down further, I would like to think, what could this look like so that we could have the calendar render, we could have frames render, we could have all of the styles render, all of these things, so that later on we can distribute that on the elements and have them render on the canvas and so on and so forth. When I say distribute, I meant style. Sorry, guys. This is a spread operator. That's how styles work here. And you can also use CSS. So, anyways, that's out of the focus of this course. So, essentially, to break this down, I would then think of 2 different approaches. I could have JSON type structure, or I could have some sort of HTML type structure. Now, to make things easier, I'm just going to use JSON because JSON is the easiest way to kind of create an engine for. So we can have a rendering engine, right? So my website builder has this Redux store that will store the data for my rendering engine. And the rendering engine will convert that Redux data into elements on the screen. So I would like to think of what that structure would look like. So I would probably need element ID, type, name, whatever that is, and if that element has other elements as well. So elements like this, which is an array. right? Because one element can have multiple children. And then the same data we have here will also be copied into this. So we have this in here, and then so on and so forth. And so now you have essentially constructed the data structure, and you also have state management kind of set up. And so you see how we have thought from a global level, and we have created this this reusable architecture that can work for all these features. And now just to answer one question, for calendar, same thing, right? We'll have the element ID calendar, name will be calendar, so on and so forth. And for the elements themselves, this would render a special type of element, right? And we might want to have a special type element here. So special element ID, and we will store that in here. You get what I'm saying? So, or maybe it's kind of like a key, and then you can map those to all your special built elements. And where would that happen? That will be the next question, right? That is the rendering engine. So this is the engine itself that is responsible for taking this data and converting it into something that can be output that can output on the canvas. And so that's why I would like to think about this first. Now, building the canvas is, I'm not going to say it's easy, but it makes my job simpler, right? Because now all I have to think about is making the canvas free flowing, making the canvas zoom in, zoom out. Those are the basic features. And then can it render one of these data structures on the canvas? Forget about the design, forget about all those funky things. Just the data structure alone, can that be converted into something that can be seen on the canvas? So I don't care about styles for now. By the way, I forgot about styles here. Probably want to add this in here. But I would just look at, can I just render this element on the canvas? And if I can, I'm happy. That kind of uh, shows that our prototype is in progress. So it's a very iterative process. Now, the challenge here becomes, how does a non-technical person actually do this? Because obviously I have years of experience, and so it's easier for me to say, think about this data structure and figure out the elements, arrays, all that stuff. It's easier for an expert or someone who has more experience than me to actually say. So how does someone with no experience do this? Use AI. Speak about your ideas, right? Speak in pseudocode. If you don't know what that is, it's not code. It's just ways to represent code. So just try to speak out your ideas to AI and get assistance by asking it to give you a roadmap, an architectural blueprint of some sort, so we can piece all of these together. Regardless, the English thinking, the simple English thinking in this is just, I have these processes in place and I need to number them down and I need to tackle them one by one. This anybody can do, right? So if you start here and you get AI feedback based on the technical implementation, then you can build complex features. In fact, my architecture might be horrible, right? Like, I'm not going to rely on just my brain here. I want to use Opus's brain, because this model is capable of so much more than you can think of, right? It is a much better developer than you are, and when it comes to building the architecture for something, at least based on my experience. So rely on this. Use its expertise. Don't try to just use yours. In fact, there are many times where I thought something was good, and then AI would point something. I'd be like, that's wrong, right? So ask AI to do all of this, but give your thoughts, and your thoughts are right here and here and pretty much here. Okay, so these things are your thoughts, and these things right down here are AI's thoughts. All right, and then later on you can combine them piece by piece and build iteratively. So now we're done with this. I do have a few more concepts we need to walk across, so let's take a quick look at those as well. So let's go ahead and scratch this out. We completed this module. Awesome. How to prompt. Boom. Done. Nice. We also covered global first thinking, right? We just introduced how to think from Redux store, from architecture level, and how to use AI to do the technical architecture part. Well, you just piece it together, right? Give it the right direction. Now I want to discuss a strategy called red-green prompting. So let's jump straight right into that one. In this module, we're going to discuss red-green prompting. Now, you'll see why this is a very unique way of prompting, and at least I think it is. But there's actually two strategies, two ways to implement red-green prompting. And the first strategy is the gap method. And so essentially what this is we deliberately create something to fail right now so that in the future, the right thing surfaces. That's what the gap method is. So you purposely miss out or you leave out something or you create an error or you do something purposely right now so that later on you can catch it and then fix it. That's pretty much it. So long story short, that's what it is. So here's a good example so you can understand this. So team invitation. Team invitation can be broken down into two different tasks. You have creating the invite and then you have sending the email itself. And most of, I guess, a bad prompt would be something like build the invite system or build the invitation system and then send an email to a customer or send the email to the invited member. So what we essentially did here is we intertwined both of these tasks. And what we lost here is this potential globalized solution that we could reuse somewhere else. So you see how sending an email could have been used for your automation builder, could have been used for your subscription providers, could have been used for in case someone's account failed, whatever it is, you could have used that here and reuse this architecture somewhere else. Maybe what I would have done is I would have had a service or a router or something here, a source of all truth router that I use for all email sending for the organization. And I would just use this and send emails through this. And so if I had approached it this way by splitting it up into two different parts, right, I could have built this section and made it easier for me to change things in the future. So the gap method essentially introduces this. And if you remember in the previous modules, I taught you how you can essentially focus on only the things that are needed now. So that way the prerequisites for the next feature are checked. That's essentially what this can help do. So here's what the correct way would look like, or a better prompt. So build an invite creation feature. Do not wire up emails yet. Just create a single source of truth function. Now, obviously, in your case, you could be a little more specific here by telling it exactly what you want. So I'm just going to say service or maybe a router or whatever you want to call that, right? Our single source of truth to create a function where the email functionality will go later on. For now, just log the message in the console. So what we did is we created a gap, right? We created a gap right here, and we're going to do this later on, and then we built this. Another thing you can do is you can offload this work into another agent, into another sub-agent. And again, that's a whole different module, a whole different course. Maybe I can create a course in that, which is how to do multiple tasks at once. So multitasking or multi-agent work, multi-agent work essentially. We'll get to that later. But in this course, I just want to focus on, in this module, I just want to focus on this topic. And so, so this is how I would prompt the right way. And so what we've done is we've created a gap that we can later on fix by completing the missing piece and just putting that right here. Now, here's a very important note. You don't want to forget about these gaps, right? And so the way to deliberately create an error is by using something like console.error or console.warn, or you could also use a warning note or a to-do note. Remember, we're trying to build guardrails here. The point is not for us to use context to remember this. So maybe this would be a better approach here. In some way, you have to figure out something's wrong. So another approach that I've implemented in the architectural guardrail is a toast message that looks a little strange. And that only shows for us as developers locally. And in production, it's not going to show because we just hide it and we just say error, something went wrong. So that's another way you could actually throw these errors so you or AI can figure them out. So yeah, I would probably lean towards something linting based or something like this. The next strategy, which is a super interesting one, is called the white lie method. And the idea here, let's see if you can guess. Just pause this video and try to guess, what does this actually mean? What do you think it means? All right, welcome back. Hopefully you got the right answer. If not, no worries. This is what the white lie method essentially is. We make a false claim that forces AI to search for something that may or may not exist. Let me explain a little bit further. So essentially, you need to understand that your default assumption decides the first action that AI will take. So if your default assumption was something like nothing already exists and build this feature, then it's going to create, it's going to write. That's what it's going to do first. But if your default assumption was something already exists, what do you think AI would do first? Search. And that's what we're trying to create here, a way for AI to search through the code base to find potential globalized solutions, right? And so most of your prompts might be using, well, not every single prompt might need this, but this is a good prompting strategy when you need some sort of globalized stuff that you believe should have been globalized to be used inside the feature it's building. And the best thing is there's no downside to this. If you're wrong, it'll just tell you, right? If not, it'll ask you to create this sort of, would you like to create a globalized solution because it makes more sense? You see what I'm saying? And maybe that's a way to catch another bug or something that you missed or something you thought you should have done in a different way. So here's a much better example so you can further understand this concept. So let's say you're trying to build invoices, right? In the invoice page, you want to show a checkout form. So a bad prompt would be something like, even if you're as detailed as possible here, this structure is still incorrect, which is add a checkout form to the invoices page with Stripe. Even if you had said something like, I want to build a checkout form on this page, the form should show in a specific way, like even the UI should look similar to other UIs, that is still incorrect, right? To other invoices or other checkout forms, that is still incorrect. Here's what the right approach would be. We already have, here's the key, we already have a source of truth for payments and checkout somewhere in this application. Use that. I wouldn't even say find it. I would say use that first because we're already assuming that it exists. Use that and wire invoices into it. And again, we're combining this along with the gap strategy. And so after this, you could say something like, once that's done, then connect that source of truth checkout flow. Forgive my spellings, I'm just making errors because I'm typing really fast. Checkout flow into the invoice. Remember source of truth. Whatever, you can say that once more. So you see how we stacked both of those strategies on top of each other. And this, like, you will see this happen. So I'll give you an example, a real world example. When I was building Mochi, in the website builder specifically, the website builder at one point had a Redux bug that I wanted to solve, but I actually kind of forgot about it. And the error was essentially the website data was getting outdated or stale because of the cache. And I knew that it's not actually the cache problem because I knew there was something wrong with my Redux store. But what I still did anyways, right, was I just said, there is a bug in the Redux store. The data is being overwritten when I'm on a different page. I know this exists because it has existed in the past. I need you to deep dive and solve this bug immediately. And while it was at it, it found another bug too that was actually the root cause of the whole problem. And it was just the issue was I built it with a singleton model, and so there was a whole error there. And so it was like the problem here is that you're storing things in a singleton, and then that data is using the cache data instead of the actual Redux data because I had a fallback. That's how I was thinking. So solve that bug and solve more bugs for me too. And so you see how it went to the absolute root cause. Another example is for one of the members inside my community, AI Era. They were facing a problem with their editor. I think they had a text editor for a note-taking app. And the problem was that they wired up in the beginning, when they first started, they had a custom editor. And it was supposed to look like Notion, but obviously it was built from scratch. So I can already tell the hell they're going to go through, right? But I later on suggested they should use Lexical. And I purposely mentioned this clearly. And I said, please remove the custom editor you have first before you migrate to using Lexical Editor. And they said they did, obviously. But then they started facing some bugs as they were just testing out the application many weeks later. And I don't know where the bug comes from because I'm making an assumption that they already removed the old code. And so when they hopped on the coaching call, I knew exactly what was going on. I was like, okay, there's going to be some sort of an iteration loop or something that's happening on the editor that is essentially looking at every single text character they were typing, which is the old strategy, which was absolutely wrong. And then I knew that that was causing a refresh every single time. And so as they type, they can see that delay, right? Because there's loops happening in the back and it's mapping through everything. And so I knew that there might be old code wired into the website builder. And I asked them on the call, I even had this recorded. I was like, are you sure the old stuff is not there? And they were like, yes, I removed it. And so what do you think I did in the prompt? Obviously, we used the white line method, which is red green prompting, which is I told AI that I have two incorrect architectures for the editor that have been mixed. And I have custom flow, and I also have the lexical editor, which is what I wanted. First, I want you to verify that my claim is true. Next, I want you to completely strip out anything related to the editor so that there's zero references to the editor in my app. And guess what I found out? Obviously, the old stuff was still not removed. It was still wired into the lexical editor. And so that red-green approach helped us kind of reveal what was hidden and that we actually missed and that AI also missed. So that's it for the red green prompting module. So let's go ahead and check this module out real quick. Right there. This is pretty satisfying, isn't it? Boom, done. Nice. And that brings us to our final module. And that brings us to the last module in this course, which is staying in control. So if you've ever felt like you don't know where things are going in the code base or you're losing confidence, it's probably because you are not creating a new branch for every feature. Even if you are creating an iteration of the current feature, just create a new branch. When you can see the files that Claude has touched, it gives you the confidence that and in clarity that Claude made the right move. So start implementing this starting today. It's going to make you feel like you're more in control of your code. Also, don't stop here. Continuously improve your learning, right? Like you need to improve the architectural guardrail as much as possible. And if you see something working, please share it in the comment section down below. I'll be more than happy to review this for you. And that's pretty much it for this course. Now, if you're ready to take your AI development skills to the next level, then the next few minutes are for you. I have something to offer, and I'm sure it's going to help you speed up your AI development workflow and at the same time make this process a whole lot of fun. I'd like to introduce you to AI Era. It's a school community I created for web developers who are looking to build production-grade apps only using AI. And the reason why I'm so confident I can actually deliver on this promise is one, you already have what it takes. You are a web developer, and so you're going to get better results. Two, it's because you're going to get the exact same architectural guardrail, the same implementation that is done for you on day one. That means you're going to get access to the architectural guardrail so you can download it and start on day one. I constantly improve and update this architectural guardrail every single week, so you will be up to date with the newest and latest AI development strategies, specifically what I am using to build my apps. The other reason is because I myself have built dozens of apps. And I also built funnelmods.ai and Mochi, which has over 1,200 features that were built to production in under 4 months only using AI and myself, right? And so I've seen everything. I've built features like website builders, form builders, automation builders, agentic features, pretty much everything you can think about. And so I know what goes into building production grade apps. Not just that, I've also made hundreds and thousands of dollars through a software licensing model that I'll be more than happy to teach you in here if you're looking to monetize your code as well. And on top of this, I've also worked at multi 10-figure companies. I've helped them build apps from the ground up. And so I've seen what goes into building apps at such a large scale. I'm sure I have a thing or two that I can help with when it comes to building with AI. So like I said, guys, on day one, when you enter the community, you can download the architectural guardrail and start. First thing I want to point out is the focus of this community is not hours and hours of courses. My promise to you is that when you join the community, you will have a simple 3-step process. And we only focus on implementation. The information will always be for free on the internet. But I know the gap exists with actually doing the work and getting the outcome. And everybody's situation is different. You might be stuck and you might not know how to, vibe code or plan a feature to start building it using AI. And the reason why you can, I believe you can get support and pretty much never be stuck again is because I send custom Loom videos to every single member of this community. There are hundreds of members in here who are sending their ideas. I approve them, I give them suggestions, and I help them through the 3-step process that I was talking about, which is build, sell, build, launch, and scale. And so in the launch phase, I'll show you the models that will work in 2026 because SaaS is kind of, it's changing, right? You can't really create a micro SaaS anymore. And the only way to kind of survive is through this newer approach that that even Saeed is using now, which is systems as a service. So what Saeed does is he charges, just to put this in perspective, he charges $3,500 per month for the software he built in under 4 days after joining AI Era. And it's the same software that other people charge $30 per month. How was he able to do that? Well, that's because of a system as a service model. And that's exactly what we teach inside the community as well. And there's other models that you can follow too, based on your idea. It's just a simple plug and play type, coursework. That's what I wanted for the community, which is implementation focused only. And that means when you enter the community, you just plug in different models into your app idea and you just start building, right? And there's a ton of other testimonials I showed you in the beginning, but here's Ruby, guys. I showed you this in the beginning of this course. The app he built helped his brother save hundreds of dollars a month. And he shared his app here. If you guys want to take a look at it, feel free. Just don't spam, please. Be respectful. But he helped his brother gain 12,000 followers in a week. That's so nice, right? And I believe that the only reason why these guys got these results is because I was able to assist with not just Loom videos, but also coaching calls. And so implementation is the only missing piece. And I believe there is a gap there between knowledge and actually doing the work. And having somebody who's already done all of this and is constantly doing this every single day by your side is definitely going to help. And so if you believe this is going to support your journey in some way, then definitely take a look at AI Era. The link is down below. You can go to school.com/AI Era and you can start today. But regardless, I hope you take all of the concepts that you got from this course, do something cool with it, and tag me in a post or whatever on Twitter. I'm looking forward to seeing what you guys have to build. And that's it for today's course. If you have any other suggestions or questions, put it in the comment section below, and I'll answer them in the next video. With that being said, I'll see you in the next one.